Let's start. This is lecture number 7 in blockchain technology and applications. The same slide you see in every lecture, the resources, and this is the outline from the previous lecture. That in previous lecture we did a review that we'll keep doing in every lecture. But then we spend a lot of time in understanding digital identity, and then we discuss Ethereum, which is one of another cryptocurrency, Ether, and there's a framework, and it has additionally the concept of smart contract. So that makes Ethereum not only a cryptocurrency, but also you can implement smart contract. But it's a permissionless public blockchain. A permissionless means anybody can join. Like we did last time, that anybody who just downloads a digital wallet can just be part of this network, and you can write your own smart contract. But then you have to pay in Ether for all the nodes in this permissionless network, for all the nodes to actually execute what you want in the smart contract. Okay, so it may be a smart contract between two people, but if you want to use a public Ethereum framework, you'll get into that ledger, open ledger, which is open to everybody. All the nodes will also execute it. Okay, so sometimes it does not make sense for a smart contract to be part of a public blockchain, okay? Because it does not make any sense that everybody in the world figuring out that you are buying a McDonald's or pizza, or you are sending a few Ether to somebody. So it does not make sense, even in a supply chain and in other applications. So in Ethereum, either you make a local copy, but even if you make a local copy, because Ethereum is designed for permissionless public blockchain, so a local copy will also go through the same steps, the proof of work, the mining, so because it is in the framework. So that necessitated the need for yet another blockchain, where there should not be any cryptocurrency linked to that blockchain, number one, where it must be permissioned blockchain, where somebody allows, like our WhatsApp group. Okay, so there are currently 2 administrators. They allow who all can be part of that group, and whether they can. So even we have provision to restrict what a member can do in that group. Okay, so this is kind of an example where I don't want everybody to know that who all are there and how they are linked and what are the permissions different people have. So almost the same concept, that you can allow few as to work as administrator, controlling that who can do what, and who does that? The organization or the person who basically start a network, he has the control. So he has the control to assign that, okay, you have these rights, and you can revoke also the right of somebody, and you can throw him out, bring somebody in, and bring multiple organizations in as well. Okay. And so today I intend to still do a quick review of the core concept, but then something which is very important for smart contract, and especially for even permission blockchain, because even permission blockchains are across 2 organizations. Example is, let's say 3 universities, CASE, FAST, NUST, and with HEC. They want to form a consortium where they just let students, take courses from any one of these institutions, and they want that course must be counted towards their degree program. But then it is governed by a smart contract. A smart contract means like a student of CASE going to FAST, taking a course, and there's a difference in fee structure. Okay, there's a difference maybe in the way they grade. There may be a lot of differences. So the smart contract shall govern that how the FAST instructor is going to grade the student, so that we can put his grade in our transcript. And number two, that what shall we do with the difference in the fee structure? If, let's say, fast charges more, should we request fast to charge less? Okay? Or if they don't agree, then who is going to pay, the delta? So it becomes the part of the smart contract. And we say, okay, the student should pay, or the case should pay, or we come up with another arrangement. So we sit with them, and we come out with an understanding. And that understanding is then coded. And now you have to build a permission smart contract where some of the entities in case, so case as an organization, some of the entities in case are to be part of the network. So who are those entities? Maybe our registrar office, our controller examiner, our dean of academics, our head of the department. From our side, they become part of this whole network because they are the concerned entities. Okay, and then similarly on the fast side, there'll be few people. Then from NUS side, there'll be few people, and maybe HEC may want to see what is happening. Okay, so because HEC governs the overall, so you may or may not want, but you may want them HEC just to be part of this whole network so that they can at least see what is happening. Or it may be that you don't let them just physically do anything, but all the transactions that are happening, HEC can actually see that what are the transactions that are happening. So if you try imagining, it gets more and more complex. Okay, so you basically within case you are taking courses, the students in fast taking courses, they're taking courses, and then you invoke the contract once there is a relevant transaction. So you invoke the contract. So building a framework, a generic framework that could basically handle any kind of these contracts across the organizations, wherein every organization there are entities, but then there will be an entity which is setting up everything, the administrator, that who should all be part of the contract, who are the peers, and what kind of access should they be given, what are the client applications, which perhaps every student has an application where he is applying, and so this becomes very intricate. So it's also like amazing that people could actually build these type of frameworks where no matter what type of contract it is, you can just use the framework. Right? So it is that generic. Bitcoin is the simplest. अगर हम देखो, Bitcoin is the simplest. All it does is that it just runs a script and it takes a UTXO money and then just give it to another UTXO. So you just only have to mention from this address, give the money to this address. That's all the Bitcoin is doing. So it's very simple to implement, obviously. And sometimes simplicity means it is very stable as well. Okay, but then Ethereum gets a little more complicated because it said let's not just use a script, let's use a torrent complete language where you can write a program and the program can have classes, inheritance, for loops, just a complete programming language. Means just you can code any complexity into an Ethereum, but then the framework is very simple. Okay, there are no access mechanism, anybody just can be part of the network. Whatever code you write, every node will execute and it'll make a Ethereum virtual machines on which the code will run. So as I mentioned earlier, our focus is more to learn how can we do smart contracts. How can, once in our country, Pakistan, we are digitalizing, why not to make use of blockchain technology, which gives you so many benefits. Okay, so our purpose is that we learn. Electronic voting machine. मैं Ethereum virtual machine कह रहा था, but yes. उसका कोई मकसद नहीं है वैसे. I have not gone into that. जो e-voting in blockchain is that no matter where you are, so you vote. Okay, so you just have a client application, okay, and then you become part of the blockchain network and you are voting. You don't have to go to the polling station. If you are in a polling station, then you don't need blockchain. It's just a voting machine and you are casting your vote, and all you need to do is just encrypt and there is no backend. They are saying it is not connected. I have not really gone inside what they are developing, but I can do that. But I'm sure it is not blockchain. Just it's my first guess. If you're going to the polling station to cast your vote, and only you need a connectivity to the backend, you don't need blockchain. And especially once you are not even connected. Okay, that's what they are saying, that this machine is not connected to the backend. So primarily, how to my perception voting machine works is that Nadra puts in all the CNICs, and if Nadra may want to, the fingerprints, into a computer for a specific polling station, like they generate list. Now here is a computer which has list of all the voters, and you go, you show your ID card, and once you enter the ID card number, and it just checks whether you are really part of the polling station or not. Okay, and there they may have a digital certification. Okay, so it's kind of a blockchain, but it is a digital certificate that nobody can mend the list what they have put into the voting machine. So there is a certification from Nadra, maybe from Election Commission of Pakistan. It says this voter list, this CNICs cannot be tampered. Right? And once you cast a vote, it may also authenticate, put just the signature that once it is taken from there, nobody can actually change that. So perhaps that type of a certification mechanism. So today we'll study about the digital signature in a transaction. Becomes very important. And then we need to understand what is man-in-the-middle attack. Okay? How can a digital signature be compromised? Right? And then the PKI, public key infrastructure. So it is very key to understand the smart contracts, because it's all, as we are discussing the voting machine, it's basically that you want to authenticate that it is coming from the right source, and you want to have confidence that nobody has changed the information. So the man-in-the-middle attack is very key. And in voting machine, what is man-in-the-middle attack? Okay, somebody is bringing the voting machine, and he add or delete some of the IDs. Okay, but there is a hash, and if the whole list is signed by the private key of Election Commission of Pakistan, then obviously it'll say the machine is invalid, because somebody has, as a man-in-the-middle attack, somebody has tried to change the list. But if it is not signed, anybody can just change the list. Okay? Or if somebody has the private key of and that's why perhaps people are scared. What if somebody has the private key of the Election Commission of Pakistan? So then you can just regenerate the signature, and you say, okay, these are the signature, and nobody will ever able to figure out. Okay. So we learn about these and the smart contract in Hyperledger Fabric, which is a permissioned blockchain, which is where you allow people to be part of the net. Not everybody can just be part of the network. So aap isme, as an administrator, system administrator, you allow that, okay, this peer can be part of the network, this peer can be part of the network. So that is the difference. So hashing, I hope that we understand pretty well, but let's spend a little more time in understanding the RSA, where RSA, and today I'll show you a utility, and I intend to generate a digital signature on a document, and just show you that how it is done, and then we'll see that it ensures that nobody can tamper with that. So the RSA, we know that everybody who wants to be part of the RSA generates a pair of public-private key, and for a person it is usually a wallet, and the private key is safely secured in the wallet, and public key you share with people with whom you want to do your transaction. And we also understand that how the RSA works is that it takes two large prime numbers, multiply them together, you have an n, and then you do p minus 1, q minus 1, find out an e which is relatively co-prime, which is relatively prime to this product, and the magic is in generating a d which is inverse of e modulo. So once you multiply d with e and you take modulo n, so you should get 1. Okay? So the magic is in generating the private key, which is d. And why the magic? Because if you have a public key, you encrypt a message with public key, which is just taking raised to the power modulo n, and then you take power of d modulo n, you get the message. Or if it is encrypted with a private key, then you can decrypt it with a public key. So this is the important relationship. See? These are some of the utilities which I want you to use, especially once I'll be giving you an assignment. This says Rsa Calculator. Okay? Let me show you this. And so in this Rsa Calculator, you can just use two large prime numbers. So he has given some, let's say I put 197, and this is only for understanding, and I put 29. Okay, these are the, and then I say calculate. So it multiplies these two numbers. Then it does p minus 1, q minus 1. Okay, so it is this number. Now he needs to find out E, which is relatively prime to this. And he said E is 3, for example. Just a simple example. And then he needs to find out that if you multiply D, E with L, so you should get 1, inverse modulo of E. So it comes out with this number. So this is the private key, which is E comma N. This is the private key, and public key is D comma N. Okay, so this is the public private key pair. And then you can encrypt any message. Let's say I write my name. Okay, and I say encrypt. So this is what it takes. This is the ASCII of my name, SHOAB. This is the ASCII value. And this is the encrypted. So it takes this raised to the power message, raised to the power E modulo N, raised to the power E modulo N. So these numbers, so I can now this, okay, and using, so this is, if it is signed with my, if it is encrypted, E is my public key. Okay, now I'll be decrypted with my private key. So I say decrypt. So decrypt, so it shows SHOAB. So this is the whole process of RSA, that, and in the background this is what is happening. So it is generating large prime numbers, but what you see is only a public private key pair. Okay? So here is yet another utility. This is called Crypto Online, but you can find many on the internet. There are many. This is by some Russians. So here is a key, so you can give generating a large key. So you say generate. This is the key. Okay. So minimum is 512 bit to be just safe, but you can have even a larger key. So this is your public key and this is your private key. So you have two keys that you have generated, and this is the time it took to generate. We have seen that it has taken the utility considerable time, to generate the key. Now what you do is you write a text message. Okay. So you write a text message and you say encrypt. Okay, so this has the encryption. Obviously nobody can figure out that what is written. And then you say decrypt. So these are some of the utilities that we shall be using today to sign a document digitally. So अभी हम देखते हैं किस तरह से हम document digitally. So I have given you links for this so that you can just use these to do the assignment. And we know that a transaction in a blockchain transaction is like a hash and a UTXO address and value that you shall be transferring to a public address, and script that tells that transfer this to this public address. So this is the script. So this is your transaction. So you take the transaction, compute a hash. So how do we compute digital signature? You hash and then you encrypt it with your private key and send, and the other person would use your public key to decrypt it and just make it part of the transaction, part of a block. Acha. Then the second thing we discuss, and this is what we shall be discussing today as well, is a digital identity. In case of digital identity, or even issuing maybe a certificate for this course, for example. If I want to give you a certificate for this course, so Case is the issuer. Case is going to issue you a digital certificate saying that you have taken this course. So you are this. So we will give you an application. So we will develop an application, Android or iOS, or so that basically you install in your mobile, and that converts your mobile into an identity wallet. Okay. So you invoke that application because we have developed it. So it will come here, okay, and it'll share its public key, right? Now, so that the wallet and the verifier must have the public key of the issuer, and then you tell about your registration number and your name to us, okay? So the user interface would ask you to input your name and your roll number, and if you do that, okay, and we have to create your digital identity as well. Let's not get into that, but that information goes here. It checks in its record that yes, you basically a valid user, and this is your roll number. So it generates a digital certificate for the course and make a signature and send it back to your digital wallet. Right? So now if you want to go somewhere where people are just hiring those who knows blockchain as a designer, and so you go and you tell that actually you have taken a course, and it is also you have a digital certificate for the course. So the verifier would just check. He may just show you a QRS code, and you scanning that, your certificate will go to this guy, and he would already have our public key, and he'll verify. He said yes, you have actually taken the course. Okay. So this is what we have learned, that how this whole thing works. That there is a signer and there is a data about that you have taken the course, or so the process of creating a digital signature would generate a hash. So we'll do it in a while. So you generate a hash. Okay? Hash is so you generate a hash because you cannot use. Usually we don't use public private key encryption to encrypt the entire content of the message. ठीक है? ये नहीं किया जाता. किसकी? करो. Okay, let's wait for 3 minutes. Mike की? Okay. कराची गया हुआ था 2 दिनों से. I just came last night late. Okay जी. तो आज हम ये करके देखते हैं, ठीक है? And then we'll see that what are the limitations. Okay. So you take a hash, then you use your private key. The signer is going to use its private key. So Case will use its private key to encrypt this hash and put that signature here. Signatures are usually big. We may prefer to take again the hash of the signature and put it there as an identifier. Okay. So anybody who is checking can actually no, you cannot. Okay. It may be an ID, but you cannot. Their signature has to be there as they are. Okay, now this guy who is a verifier, so he will get this whole thing, your plain text and as well as case digital signature, and he'll do the plain text to make sure that you have not changed any information or you have not generated a certificate for your friend who has not actually taken the course. Okay, so it takes a hash, and then he already has a case public key, so he decrypt and generate this hash and then compare and says that whether it is they verify or they don't. अच्छा, अब इसको करके देखते हैं. Okay, so this is, I've just shown you that you generate. So the first thing is that you generate a public private key pair. Right? So you as case, what I do is I go to the utility, I generate a public private key pair, a large key size 2046, and I have a public key which I give to all the students. Right? So this is my public key, and every student in the course I put it on the our WhatsApp group that this is case public key for you to check whether you have a valid signature or not, and also to anybody who wants to verify that a certificate is actually coming from case. And I don't even show you this private key. See? So this is very secret to me, so I keep it with me, and as a matter of fact I don't show it to anybody. Okay, so this is something very dear to me, so I keep it with me. So I can go here and generate this key. ठीक है जी, ये जो है हम इधर से 2046 कुछ भी जो लेंथ आप दे दें 2046. So I generate. So this is the key, and ठीक है, हर दफा अब it will generate. It generates a new key every time you ask it to generate because it's random. So it'll just find out two large P's and Q's and gives you just a new key, a public private key pair. So now you have a public private key pair. Now my software should generate this certificate for you. It says Sir Syed Case Institute of Technology certificate. Our student is Mr. Abdul Rahman, who is actually student of this class. And course is blockchain technology and applications. This is name of the instructor and the semester, and you may put other information as well if you want to, but this is my digital certificate. So what I do is I copy this text and take it to the hash where I was taking the hash. Okay, so I hope it's making sense. So I copy this text. Okay, my program will be doing this. I go to the utility which we already all of us know, which is the hashing utility. So we have already seen this utility. Okay. Otherwise, I'll be using a program, the API will automatically be calling a SHA-256, but here I'm just doing it manually. So I copy the information. Okay, Sir Syed Case Institute of Technology, and this is the hash. So I copy this hash. अब क्या करूँगा इसको प्राइवेट की से एनक्रिप्ट करूँगा. ठीक है. So I take this hash. कोई बात नहीं, अगर आपने मुझे कॉपी दी भी है ना, तो मैंने उनको टीए से कहा कि चेक दी वट एवर यू हैव सेंड, उसको उसी तरह से चेक करें जिस तरह से आपने भेजा है. ठीक है ना. तो बिकॉज एवरीबडी विल हैव अ डिफरेंट आंसर टू द क्वेश्चन. बेसिक एंड जीरो लेकर आने हैं बस. अच्छा देखें, अब मैं यहाँ पे इसको सो आई पुट द हैश ऑफ दिस सर्टिफिकेट एंड आई आस्क इट टू एनक्रिप्ट. ये प्राइवेट की से एनक्रिप्ट हो गया, ये मेरा डिजिटल सर्टिफिकेट है. सो आई कॉपी दिस डिजिटल सर्टिफिकेट, ये डिजिटल सिग्नेचर आ गया. इतनी सी कहानी है बस. ठीक है. So I take this, and so we understand that you generate a key pair. We understand that you take this, go to SHA-256, generate a hash, put hash here, encrypt with your private key, and put it here. और ये because digital है, you don't have to show this. Even if you show this, it does not matter. ठीक है? और एक कर्सर बना दे. If you click, you can see the signature. सारे ये आ जाएगा. Not सिर्फ. So that's all. कुछ भी नहीं चाहिए. कुछ भी नहीं चाहिए. कुछ भी नहीं चाहिए. Yeah. कुछ भी नहीं चाहिए आपको. Not only for degrees, like for everything. लेकिन there is an issue which we'll discuss. Okay. So you understand is that simple. ठीक है. अब आप आए. अब मैं verifier हूँ. ठीक है. You go to I'm hiring people who have taken this course, and I say कि हमने इसको blockchain पे ही बनाया हुआ है, तो I'll just verify. So verification by a verifier. अब वो क्या करेगा? He gets this text. ठीक है. वो भी इसको copy करेगा. SHA-256, and he'll create a hash for this. ठीक है. So he goes there, put this information, पूरा जो आपका certificate है, और वो ये generate कर लेगा. SHA-256 says okay, and अब जाएगा आपका encrypted message पे, वो जो आपने encrypt किया हुआ था, which is this, और उसको क्या करेगा? Decrypt करेगा, तो उसको अपनी मेरी public key से decrypt करेगा. So he is going to decrypt this with my public key. He get this message, decrypt result, and then he'll say जो उसका hash था और जो ये था वो same आया कि नहीं आया. So BA211422B7. So a computer program will check. He says yes, verified. So the both matches and they verify. So the certificate is verified. Right? So a complete software program is doing this, and you don't have to go to anybody, to HEC, to this or that. आपको कुछ भी नहीं करना. आपको automatically you only need to have a digital wallet, only need to apply for a digital certificate. Let's see if we can do this. Okay, I'm trying. So if we can build this on a Hyperledger, an ID, so every student should have a digital wallet, an ID, and then you can just request your certificates, your transcripts, verifiable transcripts from case. So we are trying to do that. So, but now there is an issue, and the issue is called man-in-the-middle attack. See? So a man-in-the-middle attack. What if like you are using here on a Wi-Fi? So I basically decipher your message once you are requesting to case, or the case is sending you its public key. So I'm just sitting in between because I am in promiscuous mode. I am seeing entire traffic in this Wi-Fi network. This is very simple. Okay, you put your device in promiscuous mode, and you just bring in every message that is happening on a Wi-Fi in this network. Okay, and similarly you can do this with the router switches. You only have to go and tap the line, and just in promiscuous mode start getting entire traffic to you, and you are targeting a particular person that you know that this person case. So basically, so you are sitting on anybody who is coming to the case website, so you are sitting in between. Right? So this is called a man-in-the-middle attack. Because man-in-the-middle attack is that if somebody can get into your communication without you ever knowing what is happening. Okay? So let's say this is case or a bank or any entity, and you are a user. आपने website open, even you are Facebook, so you say facebook.com, okay? And I am seeing that you are trying to go on Facebook. I present you something which looks exactly like facebook.com. जी? नहीं, मैं बताता हूँ. जो मतलब जो प्रोटोकॉल है ना, वो ये है कि you as a person, Facebook को तो नहीं पता आपकी पब्लिक की का ना. You are accessing facebook.com. ठीक है, मैं बीच में बैठा हूँ. मैंने कहा this is facebook.com. You exactly see the same screen. I am presenting you the same screen, same username, password. ठीक है, and you say अच्छा चलें ये facebook.com है. And I also tell you that this is my public key. Send me your information using this public key. So I am this. Otherwise, how it happens? फेसबुक के ऊपर या बैंक के ऊपर या केस के ऊपर आप जा रहे हैं, सो हाउ इट विल हैपन दैट केस विल सेंड यू इट्स पब्लिक की, जैसा अभी हमने बात की कि वी सेंड यू आर पब्लिक की, एंड सो दैट वंस आई encrypt something with my private key, you should able to open it. Okay, but what you do with this public key, because you don't want to send even your information, that certificate, in plain text. On Facebook, you don't want to send your pictures, your messages. Same is the case with Twitter, or especially the bank transaction. You don't want to send your transaction. May it be secure, but you don't want other people to know. Right? So what you do is that your software generates a symmetric key, a key. जी 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 TLS इस तरह से काम करता है, जो इंक्रिप्शन की कीज है. अब वो सिंपली है कि बैंक की एप्लीकेशन पे गए एंड यू बिफोर इवन यू पुट योर यूजर नेम एंड पासवर्ड, बैंक वांट्स टू मेक श्योर दैट वट एवर इन्फॉर्मेशन यू आर सेंडिंग टू द बैंक इज इनक्रिप्टेड. सो बैंक ने आपको जैसे ही आप वेबसाइट पे गए, इट सेंड्स यू अ पब्लिक की. सो यू रैंडमली जनरेट a random number, encrypt it with the public key of the bank and send it to the bank. Okay, बैंक के लिए बड़ा आसान है, क्योंकि anything which is encrypted by public key of the bank can open it using its private key and knows a symmetric key. We will also cover this symmetric key encryption कैसे होती है. See, and now there are keys, and आप उसको आपस में जो भी information है you encrypt and you send. And symmetric key encryption, you need the same key to encrypt and decrypt. और जो public key encryption, you need different keys to encrypt and decrypt. So this is the difference. So now this guy is the baddie who is just sitting in between. Okay, once you go to the bank, ठीक है, instead of sending the public key of the bank, वो उस तरह का आपको present करता है, send you a public key of his own, और बैंक से भी वो कनेक्ट होता है. बैंक से कहता है ओके ये है, और बीच में आपसे भी कनेक्ट हो जाता है. ठीक है, सो इट सेंड्स यू पब्लिक की. आप कॉन्फिडेंस होता है आपको कि ठीक है बैंक से पब्लिक की आ गई है. यू जनरेट अ की, एंड ये इंक्रिप्शन है जो बाहर ये हुआ हुआ, इट मीन्स के आप उसे इंक्रिप्ट करते हैं आप. ओके, और आप कहते हैं लो जी ठीक है. अब ये बैंक की तो है नहीं, ये बीच में बैठा हुआ है, ये वो की पकड़ता है, and then it just decrypt that, and then it goes, because it is connecting with the bank at the back end on your behalf, so it gets the bank's public key and it encrypts again the symmetric key using the bank public key and send it to the bank. बैंक अपनी private key से उसको करता है, and now 3 people have the keys, the symmetric key, you, the man in the middle, and the bank. So a transaction will come to him. He may want to change it. ठीक है, he may want to change it. He may want to see what is happening. He may send it to some other bank account जिधर आप ट्रांसफर किसी को कर रहे हैं, वो जा कहीं और रही है. So he can do anything because he is sitting man in the middle. So man in the middle attack usually is the only way to find out what is happening if 2 people are doing which they say end-to-end encryption. So if you come in between smartly, okay, so you can do launch a man in the middle attack, okay, which is very serious. Okay. So to counter this, इसको So to counter man in the middle attack, so there is this concept of certificate authority. See, and this is very important because this is going to be also part of the smart contract, blockchain, that there is this concept of certificate or certification authority, CS. Okay, CA basically certify that this public key coming from the bank is actually the public key of the bank. So there is a certification, notary public है कि there is a certificate, ठीक है, that this key coming from, and who gives the certificate? The CA authority. ठीक है, ये कोई physical एक authority है, you have to pay to get their services, और इस पे लोगों का trust है. So these are the trusted entities, and they'll charge you money. Okay, they'll charge you $9, $10 in a year or 2 years to use their services. And so what are their services? There are very few known entities, and these entities are called certificate authority. So you can choose your own, but the browsers, all the browsers and operating systems, they trust these certificate authorities, and they embed their public keys in them, like Firefox है या आपका Windows है, इनके अंदर they have already the public keys of CAs in them. So that is the trust. Okay, so means that you got to if case, I'll show you that case certificate in a while. So if case wants that no man in the middle attack should happen, if case is doing a transaction, case and the student, because your transcripts are there, you can go online, see your transcripts, you can see, all these things. And even in banking, it is more critical, because you are transferring money from one account to another, and you don't want that man of the middle attack, which is very easy to do. Okay, you don't want any man in the middle attack to disrupt what is happening. So you pay this little money and get a certificate. I'll show you the certificate for different entities, and as an individual you also can take a certificate, and we will see once we give you a digital wallet how we give you basically a digital certificate. So a CA will give you a certificate, and we become a certification authority. Sir, मैं अभी दिखाता हूँ आपको, ठीक है? I'll show you the complete certificate. Okay? जी, ये मैं सारा अभी हम ये करते हैं, because this is very key to understand the whole permission blockchain. Okay. अच्छा, तो जैसा मैंने कहा, जो certificate authority या certification authority, it is a company or an organization that acts to validate the identities of entities and bind them to cryptographic keys. Certificate authority कहेगी, yes, this entity has this public key, and they'll verify the entity. For example, case applies. Case says, I am case.edu.pk, and I want to get a digital certificate from you. Okay, so I'll send a request, and that request will go to their registration authority, and they'll pose me a few questions. They say, okay, take this message and post it on your website. So to make sure that actually I am the owner of this website, and whatever they ask me, I can do that. So they may have different ways of validating. If you are a person, you may physically go to a certification authority, you say, this is my ID card, you can take my fingerprint, but I want a digital certificate. Okay, so it is their responsibility to make sure that they are not issuing the certificate to a person who does not have this website or the email address or the company or the individual. Okay, so email address is very simple, that you want a digital certificate for your email address. They send, okay, we are sending you an email, and you confirm on some other way that yes, you have received the code, or something from another email address you send that, or from the same email address you respond. So it is their responsibility to ensure. That's why they're charging you money. So they do the verification that yes, you are the guy, you are the website, you are the email address, you are the company, you are the individual. Okay, so they issue you a digital certificate that primarily serves अब आपकी authentication, that you are sure that if you are dealing with case, so you're comfortable seeing that case has this digital certificate, that the information is coming from case, and if it is signed by case, that nobody can actually do the changes in that information. There is integrity, there is encryption, there is authentication. So all these things will happen if you have a digital certificate. So digital certificate is very important, that you as an entity send an application to the certification authority. Certification authority has a way to validate whether you are the person, and if it validates, and then it sends you a certificate, and you say, now you use the certificate, and certificates validate your public address. That's it. वो सिर्फ ये कह रहा है कि सर्टिफिकेट में आपका पब्लिक एड्रेस लिखा हुआ होगा, मेन चीज जो है. सो इट सेज ओके this entity has this public address. Okay, so anybody who is doing a communication, he knows that there is no baddie who has changed the public address of the bank. Okay, because certificate has a public address. Okay, and we'll see different use cases that a person who wants to still attack, what will happen to that attack. Okay, so application for digital certificate will generate a key pair. पब्लिक प्राइवेट की जनरेट करेगा. फॉर एग्जाम्पल केस है, इल जनरेट अ पब्लिक प्राइवेट की पेयर. इल कीप द प्राइवेट की टू इटसेल्फ. इट विल नेवर शो द प्राइवेट की टू द सर्टिफिकेशन अथॉरिटी एज वेल. ओके, इल ओनली सेंड द पब्लिक की एंड अ रिक्वेस्ट एंड द मनी, ट्रांसफरिंग द मनी दैट इशू मी अ डिजिटल सर्टिफिकेट. ओके, सो सर्टिफिकेट साइनिंग रिक्वेस्ट गोज देयर. And information includes, you know, whatever information they require, and you put that information. So the applicant's private key is kept secure and should never be even shown to the CA. उसको भी नहीं दिखानी थी, और to anybody. अच्छा, अब देखिए इस जो सारा फ्रेमवर्क है, this is called PKI. This whole framework with a public-private keys are generated. Public key is sent to a certification authority. Certification authority sends you a digital certificate, and which you can actually see. And I'll show you the digital certificate of case in a while. So it basically, this whole thing is called a PKI. It's a framework. It's not a software. It's just a framework. So it works across systems, vendors.
Sir, I have a question.
जी please.
सर, अभी हम मैंने जो मिडल अटैक बात कर रहे थे, तो हाउ डज दिस सॉल्व दैट इशू?
जी, मैं अब
आई थिंक प्राइवेट की वाज ऑलवेज केप्ट प्राइवेट.
I'll show you that how it solves the issue of man in the middle attack. सही है? In a while I have few slides and I'll show you that how it solves man in the middle attack. ठीक है? तो ये हमें पता लग गया, confidentiality भी है, integrity भी है, so a digital certificate. So your question. So what is there in a digital certificate? It has a standard. It is called X.509. This is the standard. Standard requires कि जी वर्जन क्या है उस डिजिटल सर्टिफिकेट सॉफ्टवेयर की, सीरियल नंबर, एल्गोरिथम जो आईडी जनरेट करने के लिए वो कौन से हैं, इशूअर कौन है. दिस इज इंपॉर्टेंट. इशूअर इज वन ऑफ द फ्यू सीएस जिससे आपने कांटेक्ट किया और उसने आपको हैज इशूड यू द सर्टिफिकेट. देन देयर इज अ वैलिडिटी. Okay, usually for 2 years. So it says not before this and not after this. So there is a validity. Subject is public key information. Here you put the certification authority puts your public key here. So this is your public key. Okay, he puts his unique identifier, subject unique identifier. इसका भी hash लेके डाला हुआ है. And but this is important. Then he signs it, certificate signature. So he signs it with his private key. So this signature is important. उसको अपनी अपने उससे इसको साइन कर देता है. ओके, अच्छा जी, इस पूरे डेटा को उसने साइन कर दिया so that nobody can change it. इस डिजिटल सर्टिफिकेट को you can actually copy a digital certificate in a file as well. ये सारी इंफॉर्मेशन एक फाइल में डाल देगा और उसका आप हैश लेकर इसकी प्राइवेट की से करके और चेक कर सकते हो कि हाँ ये वाकई ये सही है कि नहीं है. ओके, सो दिस इज सो दीज आर सम ऑफ दीज सर्टिफिकेशन अथॉरिटी. डिजी सर्ट है, वेरी साइन है. ओके, सो दीज आर द सर्टिफिकेशन अथॉरिटीज. अब क्या होता है कि वंस यू ट्राई टू एक्सेस case.edu.pk, ठीक है, वो आपको डायरेक्ट करता है सीए आपको भेज देता है उसका सर्टिफिकेट. ओके, एंड जो ऑपरेटिंग सिस्टम है आपका, जो ब्राउजर है, it'll ensure that the certificate is actually coming from a certification authority and it validates okay, yes, this is the certificate of case. And now once you are dealing with case.edu.pk, you have a certificate, okay, which has the public key of case. So you can just do that, and you can first doing the keys exchange. You have this encrypted key. जी सीए चाहे तो वो गड़बड़ कर सकता है मैन इन द मिडल अटैक, ठीक है। इसलिए पाकिस्तान बहुत तरह से कोशिश करता रहा कि एक सीए मिल जाए। देन वी हैव फ्यू सीएस because even if you are an intelligence agency and there is a criminal and you want to do a man in the middle, you cannot do a man in the middle attack. HTTPS ने बहुत ज़्यादा constraint कर दिया। पहले there was no HTTPS uses a digital certificate. There used to be no HTTPS. Hotmail was clear, YouTube, Yahoo was clear, so everything was going in clear. And once they started using this, for example, YouTube है, and now they even want to block a specific page on YouTube. They cannot do that because you cannot launch man in the middle attack, and that all the information except the domain name, every information goes as an encrypted data. So this is, you know, a registration authority, which basically the front end entity is actually the registration authority. You provide the RA with your information and the payment. Obviously, it verifies identity documentation before confirming that the CA can issue you the certificate. But then it signs the certificate. And this is also interesting. Let's say you complain, the case goes and complains that okay, my private key has been compromised. Okay, so it again validates that yes, the request is coming from you, like your ID card. And if you lose your ID card, what you do? You have to go to the police station. You need to, you know, file an FIR. Then you take the FIR to Nadra, and the Nadra checks the FIR and only then issues you a certificate. Okay, another ID card. Now perhaps it is simple, but once the terrorism was on peak, so they were very cautious not to issue another ID card. Okay, for a lost ID card unless there is an FIR. So here it is very simple. You say that your private key is compromised. Okay, so what they do is they have a list which is called certificate revocation. Okay, which lists that this certificate, this public key, is not compromised, so it must not be used. Okay, so first, whenever somebody comes at case.edu or .pk, it checks the revocation list and it says no, case certificate is a valid certificate, and then issues you the certificate. So this is, you know, how it is ensuring. But what if the private key of CA is compromised? Then you are gone, right? Then you are gone, because अगर उसकी key compromise होगी ना, then it is a serious issue. So this is how it happens that you come to case.edu.pk. Case has the certificate, or the bank has the certificate and which has some information, but primarily it is bank's public key. So how does everyone have the big CS public key installed in the system? I said they come pre-installed in the operating system, web browser, extra. So that is basically the trust, that if Firefox has trust in you as a CA, okay, only if they have trust, they'll say okay. Otherwise, they say no, we are not going to put your public key in our browser. So the browser, and that's why there are very few. Okay, ये नहीं है कि लाखों करोड़ों हो जाएंगे, तो the browser it becomes very heavy. So, and this is the certificate standard. So this is the certificate, and now comes the man in the middle. Now answer your question. Somebody asked question that how the man in the middle attack now works, and still this man in the middle attack is sitting in between, and he gets hold of the certificate, which is going to the user who says case.edu.pk. Okay, so he gets the certificate and he wants कि नहीं मैं कुछ करता हूँ. So what he can do is he also get a certificate from the same CA. See, this is one thing he can do. Okay, he also has a valid certificate as an entity. So he says, I am this entity, this is my website, kindly issue me a certificate. So the CA authority validates and figures out, yes, he is a valid user on the internet, he has a website, domain, he issues him a certificate. So he changes the certificate of case with his certificate, okay, with his certificate which he has gotten from a CA, a valid certificate he has gotten from the CA, okay. So he has this. Now the browser checks, he says, oh, this is not case.edu, this is some other organization. Okay, so he's going to drop this. He says it is man in the middle attack because you are accessing case.edu.pk and here it would say some organization with some other website. So no browser, because browser is checking this responsibility with the browser to make sure that it ensures that the certificate is a valid certificate. So ये उसको process नहीं करेगा. I'll just drop that. It says invalid certificate or whatever. दूसरी, so it says, oh, this is somebody else. It is not case.edu.pk. It says फेंक दो इसको, परे कर दो. Now he can do something else. What else can he do? वो क्या करता है, इस सारी चीज को चेंज नहीं करता, only changes the public key. What will happen? अगर सिर्फ पब्लिक सिग्नेचर ही चेंज हो जाएगी, ठीक है. सो वंस इट वैलिडेट्स, जिससे हमने वैलिडेशन का वेरिफिकेशन कर रहे थे, तो वो चेंज हो जाएगा. वो कह रहे ड्रॉप इट, ही हैज चेंज समथिंग. इसमें इस तरह से होता है, डेफिनेट एलिमेंट से भी आप कर सकते हैं, ठीक है. So it says, so it is an invalid. It's an invalid certificate. Okay. Let's see case.edu.pk. Okay. So this is case.edu.pk. अब ये कनेक्ट हुआ है जैसे ही, तो ये बना जाएगा लॉक. दिस लॉक सेज दैट आई हैव अ डिजिटल सर्टिफिकेट. ओके, सो आई प्रेस दिस एंड इट सेज कनेक्शन इज सिक्योर. सो आई क्लिक ऑन दिस. जी, ये जो मैंने इस केस की वेबसाइट पे गया हूं ना, मुझे कह रहा है कि सिक्योर कनेक्शन है. आपने अपना ईमेल चेक करनी है यहाँ से, अपना आपने यू वांट टू चेक योर ट्रांसक्रिप्ट्स और एनीथिंग यू कैन डू, बिकॉज इट इज इंश्योरिंग मी कि इट इज योर कनेक्शन, दिस कनेक्शन ऑन द वेबसाइट इज सिक्योर. ठीक है. मैं कहता हूँ अच्छा मुझे बताओ, उसने लिखा सर्टिफिकेट इज वैलिड, यानी कि मैंने पैसे दिए हुए हैं. सो इट्स सेइंग सर्टिफिकेट इज वैलिड, कनेक्शन इज सिक्योर, एंड आई वांट टू. So I go and I say connection is secure, certificate is valid. Okay? ये मुझे बता रहा है कि किसको इशू हुआ है, case.edu.pk को इशू हुआ है. किसने इशू किया हुआ है? Rapid SSL ने इशू किया हुआ है. This is the CA. Rapid SSL is a CA. और ये कुछ एल्गोरिथम के TLS भी हो रहा है, और उसमें DV, RSA, Mixjar 256, this. अच्छा, अब मैं कहता हूँ मुझे यार ये थोड़ा सा मुझे डिटेल दिखाओ. ठीक है, ये वो है X.509 फॉर्मेट. इसमें अगर आप देखें इश्यूअर कौन है, रैपिड एसएस है. वैलिड कब तक है? इट इज वैलिड, इट इज वैलिड फ्रॉम September to 2021. ओके, और वैलिड कब तक है? ट्यूसडे 4 अक्टूबर 2022, और टाइम भी लिखा हुआ है. ठीक है, 4:59 सेकेंड्स, और वो मिली सेकेंड्स तक उसने टाइम मेंशन किया. ओके, इस वक्त तक ये वैलिड है. सो आई नीड टू get another certificate once the time expires to make sure that I have a digital certificate for my website. Then I go, subject मेरा है case.edu.pk. So if the baddie tries to use his certificate, it'll say no, this is not the case.edu.pk. So I'm going to drop that. Okay, ये public key है उसकी. Okay, so this is the public key. जी, subject अच्छा नहीं, मुझे मेरा ख्याल उसका नहीं पता. ये बेसिकली सब्जेक्ट जो उसका स्टैंडर्ड है ना, उसमें आ रहा है किस ऑर्गेनाइजेशन को दी हुई है. द सब्जेक्ट हैज देन द फील्ड दैट इट इज गिवन टू दिस ऑर्गेनाइजेशन एंड दिस इज द पब्लिक की. सो ये पब्लिक की है उसकी. ओके, सो प्राइमरीली यू कैन कॉपी दिस. सो एनीबडी who wants to check whether this information is coming from case or not, because अब जितनी information case की website से जाएगी, it is all encrypted. So all the information which is going from the case website is encrypted, and the keys are exchanged using this public key of case, and he has the public key. It'll encrypt it with case private key, which is not here, and then the person will open it using this, और उसके ऊपर फिर सिमेट्रिक एन्क्रिप्शन चलनी शुरू हो जाएगी, और इसी में कहीं उसका सिग्नेचर पड़ा होगा, ठीक है ना, ये इसका थंब पड़ा हुआ है अपेरेंटली. So this is how, and you can copy it to a file as well, the entire certificate. अब मसलन देखें बैंक ऑफ दुबई है जिस तरह से, okay? So अगर if you have this, it means it is a secure connection. अगर लॉग बना हुआ है तो उसका मतलब it is a secure connection, and you can always get the information connection is secure. अच्छा, इसमें एक और चीज़ भी मैं आपको दिखाना चाहूँगा. Okay, connection is secure, certificate is valid. अच्छा, ये नहीं, अब ये even is not showing me the information. हाँ, ये इस पे एक और चीज़ मैं दिखाना चाहूँगा आपको. Connection is secure, certificate is valid, certification path. अब ये देखिए, ऊपर क्या लिखा है? Digi cert. This is called a root CA. अच्छा, इसकी बात कर रहे थे, CA0. So this is a root CA, this is CA1. So why? Because what if the CA's private key is compromised? Okay, they don't want के सारा internet ही बैठ जाए ना. So what they do, there is a root CA who is not attached to any directly attached to any user, but then these CAs, intermediary CAs, they get their certificate from a root CA, and there could be many intermediary CAs. So you can make a hierarchy. Even once you are developing your own smart contract, you can develop this hierarchy. Okay, there is a root CA, then there are some sub-root CAs, then there are other people. Okay. Okay, let's take a break. 10-15 मिनट की ब्रेक कर लेते हैं. इसमें थोड़ा सा, दिस इज अनदर ब्राउजर. अच्छा, उसका मैं आपको जवाब देता हूँ अभी. ओके, सो दिस इज अनदर ब्राउजर which says view certificate. So it shows you the certificate validity, algorithm which is it is using RSA, key size is 2048, ठीक है, SHA-256 with RSA encryption, fingerprint जो कि apparently SHA-256 करके किया हुआ है, और fingerprint with SHA-1, the two fingerprints. Then there is this digital signature, extended key, DDDRL information, certificate policies, embedded, और ये DigiCert वालों की ये की है. Yes, so this is organization is DigiCert, and DigiCert है, और global root CA भी DigiCert का apparently इनका है ना. ये DigiCert है the CA, and the root CA is also DigiCert, the same organization. Okay, so coming back to this and answering your question कि जी पहला तो हमें ये श्योरिटी होनी चाहिए कि इस तरह की कोई चीज़ पॉसिबल नहीं है, ठीक है. सो नाउ लेट्स डिस्कस कि आप जो कह रहे हैं ना, लेट मी जस्ट गेट माय so this is CA. ब्राउजर टेम्पर हो, अपना ब्राउजर हो, you know, those are the things you can do, but people, you know, trust Firefox, people trust Microsoft. So the CA, and here is case.edu.pk, ठीक है. So it applies कि जी I am case.edu.pk, ठीक है, and this is my public key. So मुझे एक सर्टिफिकेट, आप गिव मी अ सर्टिफिकेट. सो ही वेरीफाइज इधर यू हैव टू गो टू देयर ऑफिस और डू दिस फिजिकली, और मे बी सम वे ऑफ इनक्रिप्टेड जो एप्लीकेशन जो भी इनका प्रोसेस है, अगर आप ऑनलाइन भी कर रहे हैं. तो अब व्हाट हैपेंस इज कि उसने आपको एक डिजिटल सर्टिफिकेट दिया, सही है। अब इसमें कुछ भी टैंपरिंग जो होगी, बिकॉज इफ एनीबडी ट्राइज टू टैंपर दिस डिजिटल सर्टिफिकेट, तो यहाँ पे इसके पास की पब्लिक की पड़ी हुई है सीए की, ओके। सो एनी टैंपरिंग इन दिस वुड जस्ट रिवील राइट अवे कि ये तो टैंपर हुआ है, okay? So we have seen this, that you have the digital certificate and how it happens, and we can and I've shown you digital certificates of KS or Bank of Dubai, and so no matter what site you go, you can see the digital certificate for Facebook, YouTube, Yahoo, हर एक का आप डिजिटल सर्टिफिकेट देख सकते हैं। और इट्स वेरी सिंपल, दैट ऑल यू हैव टू डू इज जस्ट उस वेबसाइट का टाइप करें आप, लेट्स से facebook.com, ओके। सो इफ इट हैज अ डिजिटल सर्टिफिकेट, इट शो यू दिस लॉग। अब ये जो फायरफॉक्स है ये इस तरह का दिखा रहा है, और सो द कनेक्शन इज सिक्योर, एंड यू से मोर इंफॉर्मेशन, and you say view certificate, okay। so ये सारा आपको उसका इंफॉर्मेशन। अब फेसबुक जो है उसने भी डिजिसर्ट से लिया हुआ है, राइट। सो इससे डिजिसर्ट का है इसके पास भी सर्टिफिकेट, एंड देन यू कैन गेट ऑल द इंफॉर्मेशन अबाउट द सर्टिफिकेट हियर, एंड ऑल्सो द पब्लिक की ऑफ फेसबुक is also there in this information. So and if आपको एहतियात करनी चाहिए, if you are on a website which does not show you this, it means your connection is not secure, ठीक है। मसलन मैं आपको करता हूँ http facebook.com, लेकिन इसने उसको फोर्स किया कि नहीं, it has to be जी, उसने नहीं राउट किया, उसने HTTP किया ही नहीं। मे बी किसी को भी नहीं राउट करेगा, है ना। HTTP पहले हो जाता था ऐसा कि आपने, हाँ नहीं, सो इट इज नॉट लेटिंग विदाउट अ डिजिटल सर्टिफिकेट, द ब्राउजर इज नॉट लेटिंग इट गो विदाउट अ डिजिटल सर्टिफिकेट, ठीक है, ओके। सो नोइंग दिस, एंड नाउ वी नो दैट इवन इफ ही ट्राइज, सो दोनों जी दोबारा बताइएगा। या हो सकता है, वो कह रहे किसी और का हो सकता है, दे मे हैव, या देयर इज, आई डोंट थिंक सो देयर इज एन इशू हैविंग, बिकॉज उनके इतने सर्वर्स लगे हुए हैं ना फेसबुक के। इट इज यूजली, सॉरी मैं कह रहा हूँ, ये यूजली जो सर्टिफिकेट इज ऑफ द सर्वर, फेसबुक हैज सो मेनी सर्वर्स ना हु आर सर्विंग यू, सो इट मे हैव द सर्टिफिकेट फॉर अ स्पेसिफिक सर्वर जो कि आपको सर्व कर रहा है ना, ठीक है ना। सो दे मे हैव मल्टीपल ऑफ दीज, बिल्कुल कर सकते हैं। दिस इज व्हाट वी आर गोइंग टू शो टुडे। यस, फिर आप खुद से करना चाहें तो कर सकते हैं, ठीक है, तो खुद इंस्टॉल करके आप कर सकते हैं, बिल्कुल। सो व्हाट ही इज सजेस्टिंग, दैट्स व्हाट ऑनेस्टली व्हाट द इंटेलिजेंस एजेंसीज वुड प्रेफर, टू हैव देयर ओन CS, एंड देन फोर्सिंग every organization in Pakistan to use a local CA. So once you have a local CA, okay, then what you can do is you can launch a man. The agencies can launch a man in the middle attack. सही है ना, if they want to on somebody, some entity. तो उसके लिए ज़रूरी है कि आपकी PKI पूरा एक, you own the PKI infrastructure. So here is the other scenario that we discussed. So we have already discussed this. We know what the certification authority is. We have seen several certificates. Okay, so we know all of this. we have seen this case and we know that लेकिन एक और मसला होगा ना, then you lose the confidence of anybody complained, then you lose the confidence of the browsers and the operating systems people that you are basically doing this, तो वो एक गड़बड़ वाली बात हो जाएगी. So because it's just about trust, that they don't just give it to anybody and everybody. So काफ़ी मुश्किल से मिलता है ये CA. You have to build, बड़ा hierarchically मिलता है. First they will ask you कि नहीं, you become just a tertiary this and they'll monitor you, and then you rise the ladder, and only then you. There is a guy who met me. There was this conference on security, and he met me. He was trying to build the जिसे कहते हैं ना कि वो जो the registration authority to validate whether you are this person or not, and he is trying to use blockchain in that. Okay, there are many people, and the consensus, if everybody says that you are that person, so only then the registration authority जो है ना issues you a certificate. So he is trying to use blockchain for validating that this person is this person. ठीक है, तो वो he is trying to contact CAs, a root CA, लेकिन he is facing lot of difficulties कि भाई इतना आसान नहीं है कि मिल जाए, and they charge you lot of money to become a CA as well, right? The root CA, you have to pay a fee to root CA to be a CA. अच्छा, तो ये so we discussed this, that if he sends his certificate, the browser will figure out that this is not case.edu pk. So he'll just drop this. The second is that if he changes the key, and again the browser will figure out because this whole certificate is signed by the private key of the CA, and every browser has public key of the CA embedded. So he cannot just play with that key. This is the trick. कि उस browser में वो जो key है ना, उसके साथ वो play नहीं कर सकता, ठीक है? Because it is running in your browser. And as somebody said, if you have your own browser, and you can then this may have, you know, things to do, but obviously people have trust on these browsers, so they use these browsers कि उनको trust है कि browser कोई इसमें गड़बड़ नहीं हो रही होगी. So we have seen this is important. We have seen how to see the public key, and this is just RSA that we have seen कि RSA चल रहा है, और इसका मतलब है just imagine that like millions and billions of times this RSA is working on the internet, that every connection people make, it primarily is running an RSA. Okay? What will happen जब ये quantum computing would break, you know, RSA? I don't know. So वो chaos होगा काफी बड़ा, and then they have to come up with, you know, other things. So this is we know this is the CA and this is the root CA, and we have now understood that this is how it works. So these are some of the CAs. This is Komodo has. This is their share in giving digital certificates to different entities. So Symantec, GoDaddy, Global Sign, Indent Trust, DigiCert, Startcom, Entrust. So these are some of these, and you can see that there are very few. ठीक है, this, and अगर कोई और होगी भी तो that entity may have very few certificates that entity is issuing. So people trust these organizations trust. If somebody would ask me to get a certificate from a Pakistani CA, so perhaps I will not. Perhaps. जी, बिल्कुल हो सकती है. हमारी हैं, मैंने कहा हमारी एक दो तीन हैं. बस once let's say if I am going to get a certificate, I will not go to an Indian CA to get the certificate. I'll make sure कि भाई मैं जिन पे मेरा ट्रस्ट है उस CA से लूँ. Unless somebody is forcing me कि नहीं तुम इधर से लो, वैसे मुझे समझ आ जाएगी कि somebody is forcing me, it means there is, you know. So it is up to you that which CA you select to get. And we also understand that it is primarily a hierarchy of trust, and chain of trust कहते हैं, hierarchy of trust कहते हैं. The end entity certificate है, this is the intermediate certificate है, which is the issuer private key से sign हुआ है. The issuer signature जो है इससे sign हुआ है, and then you can verify it with the browser verifies with the issuer public key which is embedded in the browser. Okay, उससे ये सर्टिफिकेशन को टेस्ट कर सकता है कि दिस इज वैलिड सर्टिफिकेट और नॉट. अब इधर आ जाए, दिस इज द रूट CA, ठीक है. सो द रूट CA की प्राइवेट की से साइन हुआ हुआ है, एंड द इंटरमीडिएट CA कैन वेरीफाई वेदर इट इज अ वैलिड सर्टिफिकेट और नॉट उसकी पब्लिक की के साथ. सो दैट्स हाउ इट्स अ हायरार्की.
ये केस के अंदर रूट सर्टिफिकेशन जो डिजिसाइड है और इंटरमीडिएट SSL
जी मैं दिखाता हूँ. रैपिड जी लेट मी शो यू. सॉरी अबाउट दैट. आगे था नहीं इधर भी था, मैंने स्लाइड में उसको स्क्रीनशॉट डाले हुए थे. या हियर ये Rapid SSL is the intermediate CA and DigiCert is the root CA, ठीक है. और ये the end entity है which is case.edu.pk. So you can actually for every certificate you can go and figure out who is the intermediary and who has issued the root certificate. ये आपको पता लग सकता है. तो यहाँ पे केस इज द एंड एंटिटी. सो ये जो है इंटरमीडिएट सर्टिफिकेट है और द रूट सर्टिफिकेट इज DigiCert. So this is the hierarchy that you have root certificate to intermediate certificates and to end entity certificates. Or this hierarchy can go on and on. सही है. And especially देखिए मैं if you think about this कि हम कहें पाकिस्तानी इलेक्शन जो है ना वो सारे let's take them on blockchain for example, and then for every ballot box, ठीक है, there has to be a certificate, and even for every individual there has to be a certificate, because you need to make sure that it is you who is signing and you are interacting with your particular हल्का कहते हैं क्या कहते हैं जो भी. So you need to make sure that. So you may want to have hierarchy of these, that people are going physically and showing their face if you don't want to use nadras, and then you physically issue them the certificate in their wallet and you say yes, you have a valid certificate, you have a valid certificate, and you just make hierarchy of these CAs, and you can install the CAs by yourself, और एक रूट CA हो जो कि बिल्कुल इलेक्शन कमीशन ऑफ पाकिस्तान बैठा हुआ है और जैसे या नादरा इज द रूट CA एंड इट इज इशूइंग सर्टिफिकेट. सो यू कैन वंस यू आर डेवलपिंग योर ओन CA for a very specific smart contract to conduct election, for example, or to have consensus or census and collecting data for the census. So other than you can think about just making a hierarchy of these CAs, and because they need to verify the identity of that person or individual or device or the ballot box or what. So you may want to do that, and then hierarchically there is this a network of trust which you build hierarchically. So अब इसमें आ गया कि now these all things are important for a smart contract. Why? Because as I started with giving you this example that let's say we want to have a smart contract between case, fast, and then we also bring HEC only to look that what is happening, so that HEC tomorrow must not say कि we will not accept this transcript or degree because some courses students have taken from FAST, or FAST students, actually we have an MOU with FAST, and many of our students have taken courses in CASE, and similarly our students have taken courses in FAST as well. So it was very active once we were in G5, and so HEC and then let's say NUST. Okay, so we have the smart contract, and I said so you go and first you need to write all the terms and conditions of the smart contract on a paper, so that you have an MOU and mutual understanding that this is how this whole thing will work, and you figure out all the clauses in the contract. Okay, all the clauses, registration process, how the fast is going to validate whether this person is a registered student of case, and case validating NUST, and there's a lot of basically work that somebody has to do and write a physical contract which is on the papers. And now let's say you want to take it on blockchain, okay? And you want to take it on blockchain. First thing, obviously, you need to have a CA, a certification authority in case, a certification authority in fast, maybe a certification authority in NUST, a certification. So you install a CA so that all those who want to interact must be issued a digital certificate so that they do secure communication. Otherwise, anybody can come as man in the middle and disrupt you. So maybe you ask students to physically come to case registrar office and show their ID, and then they are issued a digital certificate. Or you may find out another way where you just make sure that the certificate is actually going to a person who wants to participate in this whole setting. So you have a contract. So, and remember, a smart contract is self-executing contract. It is immutable, and the transactions that are happening, nobody can go and change them. I think we can easily secure it. So then you need to decide that who all are the stakeholders in case. As I mentioned, it is registrar office, it is the controller examiner, it may be office of the dean, maybe head of the department, right? Students affair. So they all are issued a digital certificate because they are interacting, they may be interacting with students. So they all have digital certificates so that student is sure that if he is talking to somebody, there's no man in the middle attack which is happening. It cannot happen as long as the entity with which you are communicating has a digital certificate from a CA. You don't need to go to a CA, pay $9-10. You install a CA in the network. There may be, as I mentioned here, there may be multiple CAs, and everybody is going to, because it's a question of validation. You may want a root CA above all of this, and that root CA may be at HEC if you want to. Otherwise, perhaps it is not required. But this is, and then once you have a written contract, then you code it. Okay? So then you go and you write the code which deals with all the clauses in the contract, which says if it is a valid student, yes. If it has paid the tuition fee, so maybe the accounts office basically has a database which says yes, the student has paid the fee and how to deal with the difference in fee. So that goes in the smart contract. And remember, last time we discussed a contract, and this was from the Harvard professor, that what is a contract? It is a promise, because now what we need to understand is that let's not use Ethereum to implement a smart contract, because Ethereum is public. And I was actually in NED University yesterday, and they are trying to develop a verification of their degree on Ethereum. Okay, but every student has to be charged with Ether. So if you want, because it runs on this public chain, so to execute that contract, okay, a student has to pay in Ether. Okay, and so now they are confused. And not only that, even if they say it is free for student, but they have to pay for a transaction. See, NED University has to pay for the transaction happening on Ether. So they got to have some Ether in their account. Okay, so they asked some of their alumni, and the alumni basically contributed perhaps 100 Ether for them to start the contract. Okay, so now they have Ether in their account, and they have the smart contract on the Ethereum. But then they went to the State Bank, and they wanted to take permission from State Bank so that tomorrow the State Bank must not come after them. So they went to the State Bank, they said, okay, we have this degree verification process and we want to take it on blockchain, and we have it on Ethereum, and we even have Ether in our account. Some of our alumni has given us the Ether, but the State Bank is not agreeing. They are saying that if money goes outside Pakistan, Okay, we need to understand that how the money is going outside the country, whether it is ether or dollars. So they are not letting them actually use that because of the law of the land, that money going outside Pakistan, they say KYC, because it is going to a miner. He said, who will get the money? You say miner will get the money. Who is the miner? I don't know. Right? Because you don't know who is the miner. So they say, know your customer. This is very fundamental in banking, that if you want to transfer money to any person, there is this KYC. You got to know your customer. So if you don't know your customer, know your customer is fundamental to banking. Okay? And now they are stuck, because now they have developed all the software, they have even put it on the Ethereum. So that's why I was just telling them they should not have gone for a public blockchain, because one, you don't need to. You can have just a private blockchain, and then you don't have to pay, or if somebody is paying, then you can have a payment gateway, and you get the money in rupees or dollars. So we studied about the smart contract and how blockchain is used, and I discussed few smart contracts with you, like few examples, and एक इसका हम smart contract बनाएंगे. Let's say if case, fast, nust. Let's say case and fast and nust. Two different organizations. So case and fast have this understanding, but the fast and nust has this understanding, but case and nust does not have this understanding. Okay. So let's make it a little complicated. So there is this consortium where they can do courses together, and then they have this consortium, they can do courses together, but they cannot do courses, together. But then there is an HEC which you want the HEC to see, and then there is whole mechanism where you got to make sure that all the nodes in this are certified nodes, and there is a process of payment and how you do payments, and so we try to work out on this complex contract and what framework would actually let you do that. So we know the smart contracts जो है इस automatic, ये सारा हमने देख लिया, cryptographically secure है. We discuss this actual example which remained deployed for many years. It was flight delay insurance using a smart contract, and I think it was on Ethereum. That will trigger payment automatically based on the flight information, and you get about $200 if your flight is delayed by 2 hours. So ये आसान है, हुआ उसके बैंक में ट्रांसफ़र हो जाता है, ठीक है. So ये basically the smart contract. Based on the smart contracts, company monies until a certain condition is satisfied. This smart contract is submitted to the nodes on Ethereum virtual machine. ठीक है, ये Ethereum would a virtual machine is what is a virtual machine? Virtual machine, you can have multiple machines on a single computer. Okay, it behaves like a machine. So for example, if you are running Ethereum and you have 10 contracts, and every contract has to run a piece of code, so it'll create 10 virtual machines, and each contract will be running on its virtual machine. Okay? I have seen many universities, they are very smart people, they will buy one powerful computer, and in the lab there are 40 computers. So all these 40 computers are running on one computer. There are 40 virtual machines. So they save a lot of money. They are dumb terminals, and they save a lot of money because they know that students are not using computationally intensive tasks. So they connect them to a virtual. They create a virtual machine and they connect them, and they are just working, and it looks as if they have their own machine, but actually it is. And even somebody can run a Windows, the other one can do Linux. So even virtual machine supports different operating systems as well. So we have seen that. So all nodes on the network executing the code using the EVM must come to the same result. Virtual machine, if the flight is delayed for 2 or more hours, smart contract will be self-executing and a compensation amount will be given. And they have a special language which is called Solidity. Okay? So you got to learn Solidity if you want to code a smart contract. And I don't want, like in this class, my objective is that you become a designer. ठीक है. I think designer की ज़्यादा value है than just a coder, because this way you have to learn a language, but coding a smart contract in Hyperledger is just JavaScript or Java. So any programmer can code it. It is just the design and the understanding that you want to take something on a blockchain, the design to the detail, that you give him a piece of paper के इसको code कर दो बस. Okay, so that is important, and I believe that is very valuable, and we'll see that how many of you can actually get a real job of designing blockchain contract, because it's just going like this, right? So and there are hardly any people who understand blockchain. People understand only cryptocurrency, but and once we start learning, you will find out it is very intricate. It's not easy. A lot of intricacies in that. Okay? So Solidity is for Ethereum, and so the smart contract is a self-executing code. It is connected with the machine that tells us if the flight schedule and if the flight is late or not. And it is late, it automatically just pays to the person and he's happy. So this is the company which used it for a few years, and it was in November 11th of 2019 where AXA withdraws blockchain flight delay compensation experiment. Okay, they withdraw it without quoting any reasons. So there must be reasons we don't know, but they withdraw that. Delay हो रही होंगी, या they have to pay additional for this contract to run on a public blockchain. Maybe, I don't know, but I've learned that इसका मैं पढ़ा था सारा, and you can actually go, perhaps it is there is no link, but you can go type this in Google and find out that they say they did not quote, they are not quoting any reason for this. So smart contract, a very simple smart contract. I was thinking like this could also be a smart contract कि हमारे यहाँ birthdays होती हैं, and you say you have some ethers and you say जैसी जिसकी birthday आए, like you have 10 close friends or relatives, or so you want to just send them some ether, okay, your birthday present. So every year that the contract is running, it's just checking whether 12 o'clock of that day to 2400 hours, and you just send some money to that account, and if all those people have account, so you can come up with so many examples of smart contract. Because smart contract, though it name says contract, it is just piece of code that if a condition is validated, you make the transaction. There may be a transaction which involves money, or maybe a transaction which involves, let's say, transcript. So if it checks that yes, you have passed all the 8 semester, right away it just issues you a digital transcript. You don't have to wait, you don't have to, or if you have paid for the transcript, or let's say you need not to pay, a self-executing contract will automatically issue a transcript once you have completed all the requirements of graduate studies. So if you think about this, it means that almost everything we do in our organizations, okay, anything we do in our organizations can be ported on blockchain. Okay? Local blockchains, the things are happening, people have identity, they have certificates, that nobody can come in between, and things can be very, very efficient. And that is the aim, and that's what people are trying to do, that everything can be just get on the. So we know the concept of distributed ledger, I hope everybody understand. A distributed mean it is on every node, okay? A distributed ledger का मतलब है कि a copy of it is on every node, and every node can basically verify कि yes, this is a valid ledger, a valid transaction, based on कि उसकी जो public key है जिसने transaction की है, everybody in the network has access to the public key of the person who is making this transaction, ठीक है, और उससे उसको validate कर लेते हैं. मसलन in case, for example, the issue of transcript, so we say a student is applying, so he is not a node, a peer in the in this blockchain. Who is the peer in the blockchain? The registrar office, the controller examiner, the dean's office, the student affairs, okay, the head of the department. So they are the peers, and then once you apply, a transaction happens in the blockchain that this student has been actually given, and who does that? The controller. Controller issues a transcript and sign it with his digital signature and send it to everybody. So everybody validates. Yes, this transcript is actually issued, and it becomes part of the blockchain, which only these 4 or 5 offices have, and you get a copy in your digital wallet. So you have a digital wallet, it gets a copy, and you have now a digital transcript, and it is recorded in the blockchain of case that this transaction has happened because this student has completed all the requirement of his or her degree. ठीक है ना? So, and all these nodes have a certificate from a certification authority which sits in the case, so that anybody who tries to do something, a student may try to do, transcript किसी के उसे let me get my transcript, so that the setter must not let that happen. And immutability, we know that you cannot go amend because a copy is with every stakeholder, so nobody can just go and change it. अच्छा, अब ये अगर आप देखें इसकी logically this is how it works. Okay, so this is a piece of code which is a smart contract, and this smart contract, if conditions are met, it makes a transaction. A transaction is issuing of a transcript, so it makes a transactions and write to the ledger. See, ledger में जाके एक block और लगा देगा, this is a transcript, ये issue हो गई है, इसमें लग गई है. अब इसको कोई जाके ना delete कर सकता है ना change कर सकता है. Now we know that these are the transcripts which have been issued to different students in different times, and we can always go and traverse के हाँ किन किन को हमारा issue हुआ है. Okay, अच्छा अब so and we know everybody in the offices everybody has a copy of the ledger. This is why it is a distributed ledger. Not everybody in the world, because that is stupid to put this on Ethereum and then everybody has a copy. उसको बेवकूफ वाली बात लगती है obviously. Okay, why are you putting this in everywhere? So it does not make any sense. Okay, so that's the reason either you use a local copy of Ethereum or you just use something else. Okay, and today we are going to see what is that something else. Consensus is that now consensus algorithm everyone will check and whether they have the same thing. Okay, like the proof of work, you may give a challenge, compute a hash, have 2 zeros. Okay, and then there is we will learn other methods of consensus. One is called proof of stake. A proof of stake is Ethereum is trying to do that because they now understand that they're wasting a lot of power. Then they are saying, okay, the person who is doing proof of work has to commit more money than the money involved in the transaction to the network. Let's say this block of transaction has a total of 20 ether in it. So he needs to validate that these 20 ether, all the transactions worth 20 ethers, which the miner has collected in 50 seconds, they are valid. So he commits 40 ether to the network, that if I do something, if I'm saying something wrong, so my 40 ether will go to the network. Okay, so this is proof of stake. You say I'm putting my stake and you trust me because, and then that they remain committed for some time. 40 ethers remain committed for some time, and if there is some discrepancy, then something happens that you lose the money. But then again, people with more money will be mining more because you say, okay, no problem, I can commit more money, and so people would listen to me. And there may be a mix which make the problem easier and put a proof of work. So this is the example we started seeing for a smart contract. Usually in a smart contract you get to sense smartly as well. There has to be sensors, and sensors are primarily sensing, like the question I gave you in the exam where they said no more than 5 persons should stay in the house. Okay, so means that you got to have sensors which are checking if a 6th person comes and he's staying, so the sensor should tell that now there are actually 6 people in the house. so there is a violation of the clause of the contract. So this is an example जो मैंने आपको एक पेपर दिखाया था कि भाई the seller delivered goods to a buyer and the record keepers potentially with real IoT sensors monitors the delivery and submit the reports. The protocol of blockchain aggregates these reports to form a decentralized consensus. So there is this blockchain where there are different sellers, different buyers. ठीक है? Let's say आपकी port authority in Karachi wants to have all their operation on blockchain. Okay? So if they have decided that all these, and so they have these a smart contract where there are different sellers, different buyers, their port, customer, logistic providers, all are part of the network. And the transactions are happening, sellers are selling, buyers are buying, okay? And they just collect that, put, let's say, 1 day worth of transaction into a block and make it part of the blockchain. So this is how the blockchain can work. This paper talks about that. Then we talk about this as well, another example where we said there are 3 bidders and you prefer the second price auction, second price bidder, that who has the second highest price gets the bid, and then everybody is committing money because everybody has to first commit money, then they bid. So then everybody has to be returned their money. This is the part of the contract. So there are, let's say there's a piece of art, okay, and we'll cover that. There's a piece of art and we are selling that piece of art, and this is just for public, so everybody can bid. So all those who have a wallet on Ethereum, everybody can bid. So we are selling a Picasso painting, okay, and now people are bidding. And there we may say that second bidder, the highest bidder will get. So everybody is committing that these many ether, these many ether, these many ether. So the smart contract which is doing all of this. And there is a time. So you start bid and you end bid, and then you check whether who has the highest bid. So he wins, but he only pays who has the second highest bid. So you take the difference, return the difference to that person, return everything to other, and the second highest bid amount goes to the person who basically owns this piece of asset. So I showed you the code as well, but I said the code is not important. So this is the difference between a blockchain which is a public blockchain. Okay, one thing on a public blockchain is that the transaction is open to public. Everybody can see the transaction. Everybody can see the transaction. It is just a plain text. So whatever is in the transaction, you are making it open to everybody. Number one. Number two, every node is executing that transaction if you are using a public blockchain. And sometimes you don't want every node because you say it does not make any sense that every node is executing. So it is permissionless. Anybody can join the network, whether he is concerned or not. He can be just part of the network. Okay. So you pay in ether. And it requires at this point proof of work. And the language, you have to code your contract in Solidity, so you need to learn Solidity. Okay, applications could be any because it's just a public blockchain, and the code gives you this provision of almost coding anything. So it means you can just code anything, any kind of contract you can code. Okay, ये permissioned है. So I give you an example of the group we have for this course. So only we can let people to enter in this group. So there is an administrator. If he does not want anybody, so it is permission. It is developed by Linux Foundation. Okay, there is no cryptocurrency. There is no money involved in this. You don't have to pay. If there is something which has to be paid in the contract, so you may have a gateway, a payment gateway. You may get money in rupees or dollars. Okay, so definitely it's not that you cannot have money in the contract, but then you link it with the actual money sources. So this is also good. Otherwise, money has to be in ether in this contract. You got to have ether, then you have to pay for every time somebody does a transaction, and transaction will only become valid because everybody is doing it as a proof of work. So for many applications, it does not make any sense. Okay, so the throughput is just humongous in this case. Mostly consensus mechanism is pluggable in many consensus mechanisms. Every contract may require a different consensus mechanism. Okay? So that's why it has many, and you can just plug in what you think is the most appropriate. Okay, so it's sports smart contract, and it can be coded in Node.js. So you can find a programmer who can program in Node.js or Java or Golang. So that's why I believe this is not an important part of learning blockchain. Coding is not an important part of learning blockchain. Designing is an important. It was very complex. ठीक है? Designing is once you have designed it, लिख लिया सफ़े पे, तो आप बुला के आप किसी से उसका कोड करवा सकते हैं.
जो भी हाइपरलेजर को ये सारी आप कह रहे जो ट्रेड्स हैं सारी मतलब होगी.
Yes, Hyperledger Fabric में ये सारी हैं. Hyperledger के और बहुत सारे variants हैं, but Hyperledger Fabric is the most used. So the Linux Foundation founded the Hyperledger project in 2015 to advance cross-industry blockchain technologies. अभी इसमें फिर IBM आ गई. IBM really seriously committed to this Hyperledger Fabric, and now there are 100. There are Oracle. So there are many organizations who are just committing to the Hyperledger project, and it is an open source. So you can just install it in open source, and we are actually in Care. Have developed one application which is supply chain management, and now we are developing another application. I'll see if we can do a demo here on how you do the development on Hyperledger Fabric. So not everyone can become part of the network. It is a private and permissioned blockchain. The member of the Hyperledger Fabric network enroll through a trusted membership service provider. So there is this node, and only that node can add who should be part of the network. ठीक है? He is like a system administrator. वो कहेगा अच्छा रजिस्ट्रार ऑफिस ठीक है आ जाओ, ये ऑफिस आ जाओ, स्टूडेंट अफेयर नहीं, you are not required, तो परे रहो. So he basically is add people in the blockchain node. अच्छा अब as I mentioned that it is very complex. ठीक है? Because hundreds and thousands of people are just developing this framework. And to make this framework generic, that you can do just anything in this framework. So to make it generic, there's few very complex concepts that are part of the Hyperledger Fabric, which are not easy to grab or understand. But we'll slowly try to build, and using an example, we'll just try how that example, and then we'll do a few more examples so that we become a good designer of smart contract. ठीक है? Channel, you can create multiple channels. For example, within case, if the case among themselves they are communicating, and case and fast, they have a consortium. They need to communicate with each other. Our registrar office with their registrar office, our controller with their controller. So we create a channel like a subnet. So this subnet has only the nodes which are nodes in the blockchain. So let's say this is case. Okay, so this is case, and this is fast. This is nust. This is HEC. Okay, so there are few people in case, there are few people in fast, and there are definitely few people in nust, and there are few people in HEC. Okay, but we want them to communicate with each other. Okay? So you create a subnet, kind of a subnet, and Hyperledger Fabric allows you to have, and they call this a channel. So you can have a channel, which is channel of communication between case and fast. Then you can have a channel between, a different channel between fast and nust. Okay, they may be the same entities. They are there in the fast, but now they are communicating with nust. But you don't want, and this is important, there's a privacy. You don't want anybody in case to see what is happening on the channel between fast and nust. So this is very important. You don't want कि भाई उधर क्या चल रहा है. Okay. So, and same is the case of a retailer. Let's say, खैर इधर ही बना लेते हैं, इसको भी रखते हैं keep. हाय हाय चलें. So if you think about this, you will see that this happens in so many applications. So many applications. For example, there is a retailer, ठीक है, who is selling things. अब वो हर एक की चीज़ बेच रहा है. He is not concerned. ठीक है, वो he is selling things coming from different vendors. Okay, अगर कोई ये मैं भी गया था पहचान गारमेंट, ठीक है, पहचान गारमेंट्स, नहीं बाज़ औक़ात इसको हो जाता है. एंड पहचान गारमेंट है. एंड आई हैव सीन पहचान गारमेंट इज बेसिकली a marketplace which is selling everybody's clothes. ठीक है, वो जो है कपड़ों की कोई ब्रांड बता यार, कौन सी जेंट्स क्लोथिंग है? हाँ, लिवॉइस की भी है, यहाँ के पाकिस्तानी है, शर्ट एंड टाई. अच्छा, सॉरी, इसको थोड़ा सा एक बीमारी लगती है, वो लगी हुई है. ओके, शर्ट एंड टाई. अभी डिस्कनेक्ट हो. जी, आर यू बैक? जी मैं कर देता हूँ. हैं किधर ये ज्वाइन? ज्वाइन ना, यही है ना? अनम्यूट. ओके, एंड शेयर स्क्रीन. ओके, ठीक है, आई हो गया. So there is this retailer, and retailer has different brands, but he is very cautious to monitor the supply chain of all the supplier. Okay, so he creates a supply chain. So इसने एक अपना ledger बनाया, और this is one channel, this is another channel, this is another channel. So he creates with every vendor, जैसा आपने कहा कि silk and tie है कोई, या so different brands हैं, उसके साथ he has to make sure that he understand के from where the kapda is coming and who is stitching and how is the quality is maintained in that stitching. And so he creates all these channels, C1, C2, C3, and definitely every channel, and this is just one network which he is creating. So he is the system administrator on this network, and he may have a certification authorities where he wants all the nodes so that nobody tampers. So all the nodes in every channel must get a certificate. Okay, so it's a digital certificate, so that everybody has a certificate. So once they communicate with each other, so the receiver knows that this is basically the public key of the person who is sending some information. Like case, once you are communicating with case, so case has a certificate, and you are using case public key to basically interact with case. So this is the concept of a channel. Then there is also interesting concept in Hyperledger fabric which is called a world state. Okay, a world state of the ledger at a given point in time. So there are transactions. Okay, we know that ledger records transaction. For example, there is this car. Here. So the transactions are, the car comes out of the factory, it's an asset. It has some color, it has some owner, and there may be other attributes. Okay? This is a car, make and type. आपको जी make and type of the car है. So these are very important concepts in the smart contract if you're coding it on Hyperledger. So you say, okay, this car has this asset, it's make and type, year 1999, color is black, owner is Ahmed. Okay? Now Ahmed sells this car to Javed. Okay? So a transaction in your blockchain will come. So this is a transaction that happened some point in time. Now there is another, and in that transaction the ownership would change. Now you say owner is Javed. So yeah, okay. What Javed does is he changes the color of the car to white. Okay? Because you are monitoring, there is this feature, there is this attribute of this asset, and you got to go and change the blockchain, make a transaction. That Javed, now this Ahmed it has with Javed, and Javed has changed the color of the car to white at some point in time. So you are recording in your transaction everything that makes changes in one of these attribution lists. Right? So you go, you make the change. Now Javed keeps it and then sells it to Humayun. So it is no more with Javed, Humayun. Humayun changes the color back to black. Okay? So again you make a transaction. In the blockchain you say now the color of the car is black. So all the transaction, if you want to see the history that how one attribute of this asset has changed, whether it is ownership or it is color of the car, or there may be other attributes depending upon the asset that is going through the blockchain. So you can trace it back and see कि कौन सा attribute किधर change हुआ था transaction में. But Hyperledger, to make it real efficient, and instead of the program going and finding out कि किस transaction में उसका most updated status पड़ा हुआ है इस asset का, so it becomes very time consuming because वो पता नहीं, let's say last time इस asset का color change हुआ था 2000 में, then there are so many other transactions, and just finding, definitely you can find out. You got to do a very detailed search that, oh yeah, here this is the most updated status of this asset. So I said, okay, we are recording transactions, but we will have a world state which will have the most updated status of all attributes of all assets. Because then you go and change, masalan, once it is Ahmed has sold it to Javed, you delete Ahmed and you put ownership with Javed. So world state would change from Ahmed to Javed. If you want to see that when it happened, so you can go to the transaction record and see that once it is now Javed and it was previously this. Color change white, so you go, you delete black color and you put white. So means though in transaction is immutable, you cannot make any changes in the transaction. But transaction, every transaction would update the world state, because the world state must have the most up-to-date information about the asset, about all the attributes of the asset. So every transaction basically makes a change in the world state, and then it becomes part of the block as well. So this is the world state. Then there is a transaction log. A transaction log component records all the transaction, and the world state is just a DB. Okay, is a database with GG. जी उसके अंदर बिल्कुल ही एट्रीब्यूट टाइम स्टैम्प का हो सकता है. सो यू कैन, इफ यू थिंक दैट द एट्रीब्यूट इज इंपॉर्टेंट, देन यू कैन पुट दिस एट्रीब्यूट ऑफ द के दिस फीचर चेंज ऑन दिस डेट. सो यू कैन पुट दैट. सही है ना? सो इट्स अप टू यू दैट वेदर यू थिंक दैट इट शुड बी देयर, or maybe reference of this in which blockchain block this information is there, so that if you want to trace it back, so you could do that. So, but the concept of smart, the world state is not there in Ethereum or in blockchain or in Bitcoin. So we have seen that in Bitcoin, you really have to trace the UTXOs and from where they are coming, and so this is the Hyperledger Fabric smart contracts are written in JavaScript or Java or Golang, okay, and here they are called chain code. ठीक है, एक fancy सा नाम use किया. The chain code is basically the piece of code that that is written in one of these programming languages, and the chain code gets executed. So they are invoked by an application external to the blockchain. Okay, so like आपने register कराना है course, so you have an application running, and you say I want to register a course. So this application is not part of the blockchain. ठीक है, आपने बड़ा खूबसूरत सा you have this user interface, and you have an application, and application says ये मैं हूँ, and I want to register a course in fast. Okay, we'll give you this, and then you click. So this information goes to the registrar office. Okay, so you invoke a transaction sitting outside the blockchain, and you say I want to make this transaction. I want to register a course in fast. So the registrar office gets it, and then he says, checks. Okay, if it is that you are allowed, there's a smart contract which says yes, you are a student, yes, you have paid the fee, yes, you are in the program where you can take a course. Automatically it sends a request to, on the channel, it sends a request to the fast that this is our student, this is register number, he's a valid student, this is the amount of fee, that is your share, and goes to you. So it just happens. Okay, and you get a validation from us that yes, now you are registered in this course. Okay, or part of the application. When the application needs to interact with the ledger, so you basically you are invoking the smart contract in the blockchain network. You as a user outside the blockchain network are invoking a transaction that will happen on our blockchain and through an application which sits outside the blockchain network. So chain code जो है is the code simply. उसका एक नाम है which is written in Java, Node.js or Golang, the Go language. Or it is to maintain privacy. It has the concept of channels so that other people must not figure out that what is happening. And the consensus is different ways of making sure that transactions must be returned to the ledger in the order in which they are occurring, especially if the transaction with the order is important, like somebody has changed the color to white then again red. अगर वो transaction उस order में नहीं आएंगी तो world state में state ही वो change हो जाएगी. ठीक है, so transaction has to happen on an asset if there is a change, so it has to come in the order. अब ये बड़ा एक खौफनाक सी तस्वीर है जो मैं आपको दिखाना चाह रहा था. This is Hyperledger Fabric. Okay, so this is a sample network, and we got to learn this. Okay, so this is a little challenging, but we'll make sure that we learn all these things. So why it is so complex? The reason that it is so complex because it is a generic framework. It ensures that no matter in which organization you work, okay, digitization का सबसे बड़ा challenge है cyber security. It ensures cyber security. It is embedded in the Hyperledger, the cyber security. Okay? You need to not to worry about, because of the framework itself and the deal with the security. Even the man in the middle attack is not possible. What about somebody coming and hacking your blockchain? So it's like beautiful to digitize almost any government office. Okay? It's very elegant. अच्छा, so how it works? सही है. अब देखें इसमें बहुत सारी nodes हैं, and we will spend like time to one by one to learn about these things. Okay. For example, हमने आज इस पे time spend किया ज़्यादा, so I wanted to first cover the CA so that we understand what a CA is. ठीक है. CA is Certificate Authority. It for a blockchain which you are implementing inside a network, creating a network, you don't need to go to a CA and don't need to pay anything. So the Hyperledger has inbuilt CAs that you can just invoke. So you can have multiple CAs. Now let's say these are the organizations R1, R2, R3 and R4. Okay, R1, R2 R3 and R4. Let's say R1 is case. R1 is case. This is an so this symbol is for an organization. So this symbol is for an organization. Let's say R1 is case, R2 is fast. So there is a channel, and you are configuring this channel, that who should be part of this channel. So there is a configuration. Okay, so configuration of the channel, CC1. So we'll spend more time learning over this. But so this is the channel. On this channel, you have peers, peer 1 and peer 2. These are the people who would actually invoking, who will run the smart contract. Invoke will be the application. Okay? Application will invoke a smart contract that is running in these peers. Okay? P1 and P2. Either ये smart contract run हो रहा है. So they have a ledger. A case has a ledger which is L1, L1. Case has a ledger which is L1. ये case का within इस channel का ledger है. ठीक है? It's a shared ledger. So this is the ledger with the peers on this channel, and there are these two organizations which is fast and case. So the peers are can only be from fast and case. On this channel there could not be any peer from NUST or HEC. Okay? This channel is specific to people who are from, let's say P1 is a peer from case, P2 is a peer from fast. It is their registration office, registrar office. This is case registrar office. Okay? This is a ledger where it shows the students who intend to take courses or their results or so whatever stage, whether they have paid the fee or not, and whatever you want to put in this ledger. And this office, registrar office in fast, also has a copy of the ledger. Okay? Because a transaction happens, so it goes in these two ledgers. We have a contract which may be different than a contract fast has with NUST. Okay? They are running, they may have other understandings that what to pay, who to pay, whether every student can take a course or only students with a certain GPA can take a course, So they may have their own understanding and we don't know. And they even don't want us to know what understanding they have with NUST. FAST does not want us to know that. Okay? But we have the same smart contract with case, and fast has the same smart contract, and fast and NUST has another contract. So there is another, so this fast, which is R2, has another relationship or consortium with NUST. So R2 is fast, R3 is NUST. They have their own configuration, that settings, and somebody having administrative control is doing this setting, that who should be part of the channel, configuring the channel and stuff, and so he's doing that. Okay? But this is one network. It's made it into one network, and HEC is also part of the network. But then they are private because they are private channels, and this a retailer basically is dealing with the silk and tie and dealing with somebody else, has different channels. But so here maybe the HEC wants to have look on what is happening on this channel, and you may or may not. You say no, HEC needs not to know this. HEC, you have maybe another smart contract with HEC that you will only get this amount of information. So it creates okay. Okay. So these are the applications. Okay, these are different applications. So there is this application A1, which is invoking peer 1, and the same application is invoking registrar office in fast and registrar office in case. So this is an application which is invoking. Then there is another application A2, then there is another application A3. So these are the applications which is nice user interface, and where you just providing the students to invoke one of the peers, relevant peers, and invoke the smart contract. Okay, so they can invoke the smart contract, so the transaction happens once a smart contract is invoked. Okay, so here is peer 3, and if you see, there is a consortium of R1 and R2. There is a consortium of R2 and R3, and then there is another consortium of case and R4, which is HEC. Okay? Let's say we have initiated this. We went to HEC. We said allow students to take courses, and we'll have it on blockchain. You will have visibility what is happening, so there is no hanky-panky. So and HEC agrees, but HEC does not want to be part of any channel. They say I don't want to see, you know, what is happening between fast and case or case. So they are not interested, but they are part of the network. See, they are administrator. They are part of the network. They are the initiator, so to say. They say, okay, I'll create a network, and maybe. And with case, HEC says, okay, I'll create the network, and this is, they configure the network. So network configurations, they do the network configurations, okay, and they say, okay, so this is the network, and tomorrow other universities can also join in, okay, if they want to run the same contract S5, for example, they say same contract. So we bring them here in this consortium. We say, okay, let's say UET Texla also wants to be part of us, so we will bring them here. And then there may be some other university which may want to be part of them, or let's say UET Texla also want to be part of them. They have an understanding with NUST as well, so they will also come here and here. So now you can see that you can just based on that who wants to be part of which channel, so you can basically, here is where the configuration, network configuration is happening. So NC is the network configuration, who is configuring the whole net. So go to the HEC and says, okay, we want to be, this is a very good initiative that we have taken, we want to be part of this network. And HEC say, okay, you can be part of this network. So NC is the network configuration, okay. So this guy is doing network configuration through this O4. So we'll come to what O4 is, but this guy is doing the network configuration, and at this point you have allowed, HEC has also allowed case to do the configuration as well, for example, if they allows. If they say no, you don't do the configuration, only like on our group, I am the administrator and Harun is also the administrator, so he can basically have the same privileges that I have, right? So you may have two people having the same privilege of configuring the network, or you may have just one. Okay? So this is your so the NUST has may have this peer P3 has the ledger, a copy of the ledger which is different than the other ledger. So there are two different ledgers which are happening here, and a smart contract which is different smart contract. Okay? So S6 S6. So once you have this academic collaboration, let's call this academic collaboration across different universities network. So once HEC has initiated this, and then other universities can come and join, and maybe HEC basically only basically administer whether a university has, you know, this value to make it part of the network, or they must not. Okay, or definitely the universities may also have a say through a smart contract. Yes, you can become part of this provided you have a good student, or you know, this or that. So this is how it works. So sample network has 4 organizations in the sample network: R1, R2, R3, and R4. And this is coming. I have just replaced this R1, R2, R3, and HEC just to have a better understanding. But there is this a standard document for Hyperledger Fabric. So this sample network is part of the standard document version 2.0 Hyperledger Fabric. That how you basically, how this whole, and it's perhaps 200-300 pages document, right? So it's a document, and then how to you start actually install a network and do all of this is again a lot of work that people got to learn. But many people, like system administrator, needs to learn that how to do network configuration on a Hyperledger Fabric. In organization, let's say if HEC is involved, then HEC system administrator has to learn this. That this is how he has to configure the network. So different people got to learn different things in this. because it is something big. It's not something small. It's something very big, humongous. Okay? So 4 organizations, R1, R2, R3, and R4, have jointly decided and written into an agreement that they will set up and exploit a Hyperledger fabric network. ठीक है? हमारे केस में 3 यूनिवर्सिटी HEC, they have decided करते हैं. R4 has been assigned to be the network initiator. So HEC is the network initiator. They said, I will initiate a network. Okay. So we are saying case fast NUS HEC. HEC is the initiator. R1 case, R2 fast, R3 NUS, R4 HEC. R4 has no intention to perform business transaction on the network. ठीक है, वो उनके ना कोई स्टूडेंट हैं ना, so HEC is not interested to perform a business transaction कि किसी को पैसा किसी से जा रहा है किसी, unless they want कि मुझे भी थोड़ी फीस दो हर स्टूडेंट में से, which they can always ask. So otherwise R1 and R2 have a need for a private communication within the overall network. जैसे यार हमने उनको नहीं बताना, so we should have a private communication. R2 and R3 have need for private communication. उनका वो कहते हैं हमने उनको नहीं बताना कि okay you have this network and this network. Organization R1 has a client application that can perform business transaction within the channel C1. So we develop an application and we say every student who wants to invoke a contract should just download this application. ठीक है, वो आपके पास application आ गई. Organization R2 has a client application that can do similar work both in channel 1 and channel 2. Fast ने कहा कि you can either, so they provide provision that you can invoke a contract with case or contract with NUS. तो उनकी जो application है, they can have both. They can invoke channel C1 or they can invoke channel C2. Organization R3 has a client application that can do this on the channel C2 only. NUS can only work with fast. ठीक है, fast can work with case and fast student can work with NUS as well. Peer node P1 maintains a copy of the ledger L1 associated with C1. The peer nodes अब आ रही हैं इसमें कि वो जैसे मैंने कहा registrar office हो सकता है. So they got to have a copy of the ledger, that what is happening, which student, which course, which that, which the. So the peer P1 has a copy of the ledger L1, and peer node P2 also maintains a copy of the ledger L1 associated with C1 and a copy of the ledger L2 associated with C2 because P2 जो peer है वो fast का है, so he has copy of both the ledger. And peer node P3 maintains a copy of the ledger L2 associated with C2. और जो NUS वाला है उसके पास सिर्फ ledger L2 की कॉपी है. Okay? So अब जो है HEC एक वो create करती है network. Okay? So he creates a network and start adding nodes into that. So it is the network configuration और वो बनाती है CA4. ठीक है, एक वो कहते हैं ये certification authority 4 बनाती है. Okay, so Hyperledger में it invokes a CA and start configuring the network. The network is formed when an orderer is started. So network form होता है जब Hyperledger में एक orderer which is say O4 एक entity है, जैसे ही वो start करते हैं वो create कर देता है network. Network and the ordering service comprising a single node O4 in configuring according to, अब इसमें सिर्फ एक node आ गई O4 जो कि है जिसके ऊपर ऑर्डरिंग सर्विस चल रही है आपके, ठीक है. इस कॉन्फ़िगर्ड अकॉर्डिंग टू अ नेटवर्क कॉन्फ़िगरेशन NC4. सो हाउ यू कॉन्फ़िगर इट अकॉर्डिंग टू सम नेटवर्क कॉन्फ़िगरेशन व्हिच गिव्स एडमिनिस्ट्रेटिव राइट्स टू ऑर्गेनाइजेशन R4. सो HEC हैज द ऑन द administrative right on this network. They can decide who can be part of what. So they are configuring the whole network. There is a network configure जो कि configure कर रहा है वो R4 ऑर्गेनाइजेशन है, थ्रू O4 कर रही है. O4 एक पीस ऑफ सॉफ्टवेयर है जो एक नोड पे चल रहा है, ठीक है, विच इज बेसिकली ऑर्डरिंग कर रहा है और इसने सारी नेटवर्क को कॉन्फ़िगरेशंस O4 के थ्रू होनी है. So at the network level, certificate authority CA4 is used to dispense identities to the administrators and network nodes of the R4 organization. R4 organizations की अगर कोई nodes ने इसमें हिस्सा लेना है नेटवर्क में, ठीक है, so CA4 आपने क्रिएट की है only to let HEC की different nodes to get a digital certificate. ठीक है, so CA4 उनको digital certificate दे देता है जो nodes इस का हिस्सा बनना चाहती हैं. Okay, O4 is initially configured and started by an administrator in organization R4 and hosted in R4. So जो O4 है वो HEC के किसी कंप्यूटर पे चल रहा है, इट इज इन दी HEC ऑर्गेनाइजेशन, ठीक है, उनका सिस्टम एडमिनिस्ट्रेटर है जो कि आके उसके जरिए कॉन्फ़िगर कर रहा है नेटवर्क को. सो दिस द कॉन्फ़िगरेशन NC4 कंटेन्स दी, अब वो क्या कॉन्फ़िगरेशंस की सेटिंग होगी, पॉलिसीज एंड डिस्क्राइब्स द स्टार्टिंग सेट ऑफ एडमिनिस्ट्रेटिव कैपेबिलिटीज फॉर द नेटवर्क, इस तरह की चीजें जो कि हाइपरलेजर प्रोवाइड करेगा कि यू कैन जस्ट कॉन्फ़िगर द नेटवर्क, गिविंग मेंशनिंग कि किस किस तरह की पॉलिसीज होंगी उसको देखेगा. सो हम इसको थोड़ा सा डिटेल में देखते जाएंगे. अभी हम आई थिंक दिस इज प्रीटी मच व्हाट आई नीड टू कवर. लेकिन ये मैंने आपको बता दिया, जो लेजर है ना, जो इसका लेजर है हाइपर लेजर फैब्रिक का, हैज अ ब्लॉकचेन which has multiple transaction in a block, and it has a world state. So this is the difference between a hyperledger fabric and other blockchain. Other blockchains only have blockchains, ठीक है, whereas this hyperledger has a world state. और world state में मैंने आपको बता दिया कि जितने भी assets की the most updated information goes in the world state. तो अब होता यह है कि इसमें you can get an entry because just a database. database में होता है कि अगर मैं एक एंटिटी हूं तो की वैल्यू पेयर ये होता है नेम शोएब, एज दिस मच, क्लास दिस मच. तो देयर आर कॉन्स्टेंट्स एंड कॉन्स्टेंट्स हैव सम वैल्यू. सिंपल सा जैसा टेबल नहीं हम बनाते, तो की होती है जो कॉन्स्टेंट चीज है कि कौन कौन से एट्रीब्यूट्स हैं. की आर द एट्रीब्यूट्स, दीज आर द एट्रीब्यूट्स अबाउट दिस पर्सन, एंड वेरिएबल इज द वैल्यू. सो यू हैव once you say that you have a database, it has like we have in a table कि आपने कहा नाम, ओके, आपने कहा एज, आपने कहा क्लास कौन सी है या सेक्शन कौन सा है, so all the attributes. So these constants are called keys, ओके. और जो इसकी नीचे आएगी these are called वैल्यू. से सिंपल इस तरह का डेटाबेस सेव हुआ होता है, ठीक है आपकी. एंड द मोस्ट अपडेटेड एट्रीब्यूट और की जो वैल्यू है वो वर्ल्ड स्टेट के अंदर पड़ी होती है, द मोस्ट अप टू डेटेड वैल्यू, ठीक है. सो रिगार्डिंग मी द मोस्ट अपडेटेड इफ आई वांट टू सी, बिकॉज दे बिलीव द प्रोग्रामर ओनली नीड्स मोस्ट अपडेटेड इंफॉर्मेशन अबाउट if a transaction is going to happen. So वो get कर सकता है इसको, so he can get that कि what is the most updated about somebody. Let's say कि इन्होंने कहा मैंने कोर्स लेना है, so वो देखेंगे इसके most updated state क्या है, ठीक है. His name, is he still a valid student or not, has he paid his fee, admission कब हुआ था, you know. So the smart contract will just get the most updated state and would decide whether he can he take that course or not. If he yes, then he'll update the state. Now he's taking a course from past, or he'll put it in the world state. So this is what the world state is. But the transaction, you know.
Sir, I have a question here.
जी please.
सर यहाँ पे जो रिकॉर्ड करेगा उसको ब्लॉकचेन का हिस्सा बना देगा. जिसको गेट पुट उसने वो डाटा कर दिया, वो हमारे काम के नहीं.
जी देखें, जो उसकी ब्लॉकचेन में ट्रांजैक्शन पुरानी पड़ी हुई है, ठीक है, कि उसकी ये स्टेट थी फिर ये स्टेट थी. यहाँ पे मोस्ट अपडेटेड स्टेट आएगी, वो गेट करेगा, उसमें से कुछ डिलीट करना है डिलीट करेगा, उसको पुट करके बैक कर देगा, ठीक है. जबकि एज अ ट्रांजैक्शन वही चीज इधर एज अ ट्रांजैक्शन आएगी, ठीक है. सो बिकॉज अ ट्रांजैक्शन हैज हैपेंड, अ वर्ल्ड स्टेट विल ओनली चेंज इफ अ ट्रांजैक्शन हैज हैपेंड. सो उसको रिकॉर्ड करेगा इन अ ट्रांजैक्शन, ठीक है. अ ट्रांजैक्शन में यू कैन नॉट डिलीट एनीथिंग, दिस इज इम्यूटेबल. You cannot delete anything in the transaction. So any change in the status of anything would come as a transaction. Time stamp transaction के अब ये चीज ऐसे हो गई है, लेकिन उसकी जो स्टेट है वो वर्ल्ड स्टेट के अंदर आएगी, द मोस्ट अपडेटेड स्टेट है, ठीक है. सो इफ यू वांट टू नो के किस तरह से वो हुई है, सो यू गो एंड फाइंड आउट के किस ट्रांजैक्शन में उसकी स्टेट चेंज हुई थी, एंड देन यू कैन ट्रेस बैक एंड इन द ब्लॉकचेन एंड फाइंड एवरीथिंग अबाउट दैट. तो बिल्कुल आप ये सही कह रहे हो कि ये जी
सर ये सॉरी सर आप बोले, आप कह रहे हैं.
अच्छा, मैं कह रहा था कि जिस तरह से ये है ना कि क्लाइंट एप्लीकेशन जो है, जो कि आपने लाइक डिफरेंट स्टूडेंट accessing the blockchain, so somebody has to develop this client application, ठीक है, और सॉफ्टवेयर डेवलपमेंट किट के साथ वो इसको इन्वोक करेगी स्मार्ट कॉन्ट्रैक्ट को. ओके, सो ये स्मार्ट कॉन्ट्रैक्ट वंस यू इन्वोक इट, okay, it will primarily make a transaction. If there is a valid, it will make a transaction, and the transaction will also update the world state. And so the ledger has two parts. So the ledger has two parts. Now one is the world state, the other one is the blockchain.
सर थोड़ी सी कंफ्यूजन है.
नहीं बताएं.
में जो आपकी ट्रांजैक्शन हुई है, जो अपडेट्स आए हैं, वो वर्ल्ड स्टेट में रिकॉर्ड हो जाएंगे, जो कि पब्लिक है.
नहीं पब्लिक नहीं, ये पब्लिक नहीं है. देखो, दिस इज नॉट अ पब्लिक. ये लेजर सिर्फ उन लोगों को एक्सेसिबल है जो उस चैनल के ऊपर है. इट इज नॉट पब्लिक. लेट्स से कि इफ यू आर अ स्टूडेंट, ठीक है, and you have invoked a smart contract that you want to take this course from fast, so this is a transaction in a ledger, it will be recorded as a transaction in the ledger. अगर smart contract की सारी condition fulfill होंगी तो smart contract would see कि अच्छा ये student है, अब वो get कर सकता है state इनकी from the world state, instead of searching him in the different transactions, he would say यार ये स्टूडेंट है, he is an asset of case, so he is recorded as an asset of case in the world state. Let's say he graduates, so we go and delete him because now he is no more a student, so I need not to have him in my world state because he is not now part of, but he remains live in our transaction. Blockchain के अंदर ये जिंदा होगा कहीं ना कहीं जहाँ पे कि इसका जिक्र होगा. अब देखें ये स्मार्ट कॉन्ट्रैक्ट है ना, ओके, एक क्लाइंट एप्लीकेशन इसको इन्वोक किया. ओके, स्मार्ट कॉन्ट्रैक्ट कैन गेट रिगार्डिंग किस चीज के बारे में अब ये स्मार्ट कॉन्ट्रैक्ट ने इन्वोक हुआ है, किस चीज के बारे में इन्वोक हुआ है. सही है, इसने उसको निकाल लिया. इसने कहा लेट्स से गाड़ी है जो कि बिकी है अब, ठीक है. सो आपने कहा अच्छा ये मेरी गाड़ी है जो कि अब ना आई हैव सोल्ड इट टू समबडी एंड यू आर अ डीलर एंड यू हैव ऑल योर कार्स inside, or you are a state department, vehicle registration department है आप. so आपके पास जितनी गाड़ियां की रजिस्ट्रेशन हुई है उसकी मोस्ट अप टू डेटेड इंफॉर्मेशन इज इन द वर्ल्ड स्टेट. ओके, ही सेज मैं ये LXA 2090 को बेच रहा हूं. सो यू गो, यू गेट इसकी रजिस्ट्रेशन के नंबर से यू गेट ऑल दी एंट्रीज फ्रॉम द वर्ल्ड स्टेट. सो गेट करके इधर आ जाएगी. अब स्मार्ट कॉन्ट्रैक्ट एग्जीक्यूट हुआ है, इन्होंने वो गाड़ी किसी और को बेच दी है, उसकी ओनरशिप चेंज हो गई है. ओके, सो व्हाट इट डज इज इट मेक्स अ ट्रांजैक्शन इन दिस ब्लॉकचेन कि आज के दिन की, लेट्स से एवरी डे यू क्रिएट अ ब्लॉक, जैसे आज के दिन 50 गाड़ियां बिकी हैं, ऑल द रिकॉर्ड ऑफ दीज 50 कार्स सोल्ड टू डिफरेंट पीपल, यू रिकॉर्ड देम इन अ ट्रांजैक्शन in your ledger part, and you also update now the attribute of this, that this has now some another owner. उसको आप वर्ल्ड स्टेट में जाके रिकॉर्ड. वर्ल्ड स्टेट क्या, एक सिंपल आपका एक टेबल है, सीरियल नंबर 1 से लेके 50 लाख गाड़ियां हैं, वो एक टेबल है. उसके अंदर आप जाएंगे, रजिस्ट्रेशन नंबर डालेंगे तो वो आपको इनका रिकॉर्ड दे देगा. अब आपने अपडेट किया, रिकॉर्ड को वर्ल्ड स्टेट के अंदर डाल दिया. सो वेरी सिंपल कॉन्सेप्ट दैट वर्ल्ड स्टेट हैज द मोस्ट अपडेटेड स्टेट ऑफ एन एसेट which you are monitoring or you have it in your system, and whereas the block is a traditional blockchain recording every transaction, converting those transactions into a block, appending it in a block which nobody can change. Nobody can actually change anything in a block. So every change is a transaction that is recorded in a chain of blocks. पता समझ आई? अभी भी कंफ्यूजन है? चलेंगे बस कर मैं खल ये जी ये मोस्ट अपडेटेड इंफॉर्मेशन है. जिस तरह देखें ये है, ये देखें ये वर्ल्ड स्टेट में पड़ा हुआ है कि कार है BMW है, कलर उसका रेड है और ओनर जैन है, ये वर्ल्ड स्टेट, दिस इज व्हाट इज इन दी वर्ल्ड स्टेट, दैट दे आर इंफॉर्मेशन अबाउट डिफरेंट कार्स। अब कार में ये बंदा चेंज हो गया जैन, ठीक है। सो वर्ल्ड स्टेट में अब ये वैल्यू चेंज हो जाएगी और ट्रांजैक्शन तो जो ट्रांजैक्शन है वो रिकॉर्ड होगी। let's spend more time tomorrow, not tomorrow, next week। अच्छा नेक्स्ट वीक ना मुझे एक और
कह सकते हैं सर, ये जो वर्ड स्टेट है वो जो हमारी ब्लॉकचेन है उसका सिंपलीफाइड वर्जन है आम यूजर के लिए कि ये स्टेट हो गई है इस गाड़ी में।
नहीं यार, ये देखो मैं आपको बताता हूँ। देखो एक स्मार्ट कॉन्ट्रैक्ट हुआ, आप स्मार्ट कॉन्ट्रैक्ट हुआ तो कोई चीज ऑनर, जैसा हमने कहा था ट्रांजैक्शन जो होती है वो कोई एक किसी चीज की ऑनरशिप या पोजेशन चेंज होता है, देन देयर इज अ ट्रांजैक्शन, ठीक है। तो जब किसी चीज का पोजेशन या ट्रांजैक्शन वो चेंज हुई, वो चीज पहले से आपके वर्ल्ड स्टेट में पड़ी हुई होती है, ठीक है। मतलब एक टीचर है, अभी फॉर एग्जांपल एक टीचर है, वो इस सेमेस्टर में 3 कोर्सेज पढ़ा रहा है, ठीक है। अगले सेमेस्टर में आपने उसको 2 कोर्स और दिए, अब ये एज अ ट्रांजैक्शन ब्लॉकचेन में आ रहा है, ये टीचर था इस सेमेस्टर में ये पढ़ाया, अगले सेमेस्टर में ये पढ़ा रहा है, तो जो वर्ल्ड स्टेट होगी उसमें सिर्फ इस सेमेस्टर की इंफॉर्मेशन पड़ी होगी, लेटेस्ट। वो जो पुरानी इंफॉर्मेशन है कि वो जो 3 कोर्स पढ़ा रहा था वो इंफॉर्मेशन ब्लॉकचेन में पड़ी होगी, ठीक है। जो उसकी हिस्ट्री है कि टीचर ने क्या क्या कोर्सेज पढ़ाए हैं, वो सारी इंफॉर्मेशन होगी ब्लॉकचेन के अंदर। एंड व्हाट ही इज टीचिंग इन द करंट सेमेस्टर विल बी इन द वर्ल्ड स्टेट, बिकॉज मोस्टली यू नीड फॉर स्मार्ट कॉन्ट्रैक्ट, मोस्टली यू रिक्वायर द मोस्ट करंट इंफॉर्मेशन। सही है ना? तो हम इसको अगली दफा थोड़ी सी और एग्जांपल देख लेंगे। एनी अदर क्वेश्चंस? दिस इज वेरी, ये बड़ा इंटरेस्टिंग है इंशाल्लाह, एज वी मूव इन दिस, इज वेरी वेरी इंटरेस्टिंग टू, इंट्रिकेट है लेकिन इंटरेस्टिंग है बहुत ज्यादा। तो होपफुली इफ वी लर्न दिस तो हम बहुत वैल्यूएबल बन जाएंगे इंशाल्लाह।
सर ये स्टेट बोर्ड है, इसको हम ये कह सकते हैं कि स्टेट मैनेजमेंट होगी जो एक्टिव स्टेट है उनकी,
ये उनकी एक्टिव स्टेट है, आप ये कह सकते हैं मेरा ख्याल कि दिस इज द एक्टिव स्टेट ऑफ एन एसेट।
और उनकी मैनेजमेंट की कौन सी स्टेट अपडेट,
उनकी उनकी मैनेजमेंट स्मार्ट कॉन्ट्रैक्ट में हो रही होती है, ठीक है। ये स्टेट तो एक डम्प सा डेटाबेस है, बस टेबल है ये, इट्स अ DB2, इट्स अ डम्प डेटाबेस which has value of different attributes, ठीक है। जी जी जी।
Sir, there was a confusion in today's lecture because there was a message moving on the percent that there won't be any lecture. तो बहुत सारे लोगों ने इसको मिस भी किया, कुछ लोग बाद में ज्वाइन किया। अगर आप कोई के 2-3 मिनट में इस रिकॉर्ड ऑफ लेक्चर का रीकैप कर
जी जी
वीडियो सबसे पहले प्रोसेस हो जाए।
नहीं, ये वैसे ना हमारे टीम्स उस पर भी पड़ा होता है, माइक्रोसॉफ्ट टीम्स पे भी अभी पड़ा होगा, यानी कि वंस यू फिनिश इट यू कैन जो एंड रिव्यू इट, बट आई कैन रिव्यू इट रियल क्विकली। आप कह रहे हो शुरू का पार्ट मिस हो गया लोगों का?
जी सर।
तुम्हारी खैर होगी, शुरू का पार्ट तो सारी शुरू है लेकिन मैं बता देता हूँ, नो प्रॉब्लम। नहीं, मैं जल्दी से बता देता हूँ, जो किसी ने जाना हो तो वो जा सकता है। नहीं, मिड टर्म के बारे में डिस्कशन नहीं हुई कि एंड ऑफ नेक्स्ट वीक मिलेगा। आप कहें तो मैं बता देता हूं दोबारा। हाँ, मैं बता देता हूं, आप जा सकते हैं, ठीक है सर। आज हमने किया था अबाउट कि डिजिटल सिग्नेचर का तो हमें पता था, फिर हमने डिस्कस किया कि जो मैन इन द मिडल अटैक क्या होता है, कि आपने दो के यू हैव साइंड इट डिजिटली बट देयर मे बी अ पर्सन हु इज सिटिंग इन बिटवीन, जिस तरह अगर आप अच्छा मैं एक मिनट मैं बता दूंगा। अच्छा, आज हमने ना किया है अबाउट मैन इन द मिडल अटैक। ठीक है, हमने बताया कि अभी जो हम सारा वी आर लर्निंग इन ब्लॉकचेन इज अबाउट दैट यू कैन डिजिटली साइन अ डॉक्यूमेंट। ठीक है, वो वी हैव बीन डूइंग दिस फ्रॉम स्टार्ट ऑफ द सेमेस्टर कि दिस इज हाउ यू, लेट्स से मैंने उन्हें कहा इफ वी वांट टू गिव ऑल द स्टूडेंट्स हु आर टेकिंग ब्लॉकचेन कोर्स अ डिजिटल सर्टिफिकेट, ठीक है, कि विच यू कैन शो टू एनीबडी एंड ही विल वेरीफाई कि हाँ आपने केस से ब्लॉकचेन का कोर्स ये किया हुआ है। तो हम क्या करेंगे, एक सर्टिफिकेट बनाएंगे केस, उसका हैश निकालेंगे, केस अपनी प्राइवेट की से उसको इनक्रिप्ट कर देगा और उसको सिग्नेचर के तौर पे यहाँ पे लिख देगा। और जो वेरीफाई करना चाहेगा, लेट्स से कोई कंपनी है, उसको आपने अप्लाई किया कि आई हैव टेकन दिस कोर्स फ्रॉम केस एंड दे वांट टू डिजिटली वेरीफाई, तो इन वेरीफायर को केस अपनी पब्लिक की दे देगा। आप अपना सर्टिफिकेट दिखाएंगे, वो सर्टिफिकेट का हैश निकालेंगे, हमारे सिग्नेचर को हमारी पब्लिक की से डिक्रिप्ट करेंगे, दोनों को मैच कर लेंगे तो उन्हें पता लग जाएगा इट इज यू हु हैज एक्चुअली टेकन दिस कोर्स एंड दे मे कंसिडर यू फॉर एन एम्प्लॉयमेंट। ठीक है, इसमें फिर मैंने कहा इस तरह से पब्लिक प्राइवेट कीज जनरेट होती हैं। ये मैंने वेबसाइट का एड्रेस दिया हुआ है, ये मैं भी आपको असाइनमेंट भी दूंगा। So once you go and generate, so it will every time you say generate, it will generate a different set of public and private key. Public key you share, private key you must not show to anybody. सही है? उसके बाद ये हमने ये डिजिटल सर्टिफिकेट बनाने के लिए इस वेबसाइट से मैंने 2046 लेंथ का एक पब्लिक और प्राइवेट की जो है वो जनरेट कर लिया और पब्लिक की जो है मैंने शेयर कर दिया उस कंपनी से जिसने कि वेरीफाई करना है। अब ये अब्दुल रहमान है, हु इज एक्चुअली अ स्टूडेंट ऑफ दिस कोर्स। मैंने सर्टिफिकेट बनाया केस ने, सर सैयद केस इंस्टीट्यूट ऑफ टेक्नोलॉजी सर्टिफिकेट, स्टूडेंट इज मिस्टर अब्दुल रहमान, कोर्स नेम इज ब्लॉकचेन टेक्नोलॉजी एंड एप्लीकेशन, इंस्ट्रक्टर इज डॉक्टर शुएब खान, सेमेस्टर इज फॉल 2021। इसको मैंने हैश किया इसको, ठीक है। आई गो एंड टेक दिस इस इंफॉर्मेशन को एंड यू रिमेंबर कि हमारा ये हैश वाला प्रोग्राम है, इसका मैंने आपको उसकी वो वेबसाइट दी हुई है, उधर गया, इसको मैंने पेस्ट किया, उसने ये हैश नीचे निकाल दिया। ठीक है, सो ये हैश आ गया आपके सर्टिफिकेट का, अब्दुल रहमान साहब के सर्टिफिकेट का हैश आ गया। मैं गया इस हैश को यहाँ पे लिखा और इसको ये प्राइवेट की जो थी मेरी उससे मैंने इसको इनक्रिप्ट कर दिया। सो वंस आई इनक्रिप्टेड विद माय प्राइवेट की, सो ये इनक्रिप्शन का रिजल्ट है, दिस इज माय डिजिटल सिग्नेचर। सो दिस डिजिटल सिग्नेचर, आई टेक दिस डिजिटल सिग्नेचर और अपेंड कर दूंगा मैं इस सर्टिफिकेट के नीचे, बिकॉज ये आपके कंप्यूटर में आपके मोबाइल के अंदर होगा, सो यू कैन क्लिक एंड सी एक्चुअली द डिजिटल सिग्नेचर। ओके, अब ये जो कंपनी जिसने वेरीफाई करना है वो ये डिजिटल सिग्नेचर देखेगी, इसको डिक्रिप्ट करेगी और इसका हैश निकालेगी। इफ दे आर सेम, वो कहेगी हाँ वाकई इस बंदे ने केस से ये कोर्स किया हुआ है। ठीक है, तो हमने बता दिया वेरीफायर किस तरह करेगा, वो आपका सर्टिफिकेट की इंफॉर्मेशन को लेगा और उसका हैश निकालेगा और फिर इसको हमारी पब्लिक की के साथ डिक्रिप्ट करेगा, तो ये हैश वापस आ जाएगा। अगर सेम होंगे तो वो कहेगा हाँ आपने ही किया हुआ कोर्स, सो ही विल कंसिडर यू फॉर इंटरव्यू और अ जॉब। फिर मैंने उनको बताया कि इसमें मसला सिर्फ ये होता है अ मैन इन द मिडल बीच में आके बैठ सकता है, सो इज द मैन इन द मिडल। वो ये करता है वेरीफायर को ऐसे दिखाएगा जैसे कि वो बेसिकली केस है। ओके, सो ही गेट्स इन द मिडल और जो मैं पब्लिक की भेज रहा हूँ केस किसी वेरीफायर को, कंपनी को, वो उस पब्लिक की को वो ले जाएगा और अपनी पब्लिक की जो है वो भेज देगा वेरीफायर को। सो ये बैडी है, बैडी इज अ बैड पर्सन, ही डज नॉट केस की पब्लिक की को नहीं, अपनी पब्लिक की उसने भेज दी। सो हमारे वाईफाई नेटवर्क के ऊपर उसने ये लगाया हुआ होगा अपना एक सिस्टम चुपके से आके, और हर वक्त वो देख रहा होगा कि हु इज एक्सेसिंग केस वेबसाइट एंड हु रिक्वेस्ट फॉर वेरिफिकेशन, एंड जैसे ही कोई वेरिफिकेशन के लिए करेगा तो ही विल सेंड हिज पब्लिक की टू दिस पर्सन द वेरीफायर, और वहां से ये फिर बैठ के इसको या जो कीज एक्सचेंज हो रही होंगी, ये आप थोड़ा सा लेक्चर में देख लीजिएगा, ही विल हैव एक्सेस टू द की, और बीच में ये जो केस के और वेरीफायर के दरमियान में बैठ के ही कुड अमेंड द इंफॉर्मेशन एंड सी व्हाट इज हैपनिंग। तो इसके लिए फिर मैंने बताया कि सर्टिफिकेशन अथॉरिटी होती है और वो डिजिटल सर्टिफिकेट देती है, और फिर मैंने इनको दिखाया कि केस ने केस की आप वेबसाइट पे जाएंगे तो केस की वेबसाइट के ऊपर यहां से आगे आपने अगर अटेंड किया हुआ है ये केस की, ठीक है, तो ये वहां पे ये लॉक बना हुआ होता है। इफ यू क्लिक ऑन दिस लॉक, ये आपको दिखाएगा कि केस ने ये सर्टिफिकेट लिया हुआ है और उसमें जो पब्लिक की है केस की वो आपको नजर आ जाएगी। दिस इज द पब्लिक की ऑफ केस, और इस पे डिजिटल साइन हुए हुए होंगे जिसने ये इशू किया है हमें। सो देयर आर कंपनीज जो कि सर्टिफिकेट इशू करती हैं, दे आर वेरी फ्यू। तो ये कंपनी का नाम है रैपिड SSL, जिसको हमने फी देकर ये सर्टिफिकेट लिया हुआ है, और ये रूट CA है, डिजीसर्ट। और ये कंपनीज हैं जो कि सर्टिफिकेट्स देती हैं, कोमोडो, सिमेंटिक, गोडैडी, और इनकी पब्लिक ही एम्बेड होती है ब्राउजर के अंदर। सो नोबडी कैन एक्चुअली फाउल दिस। तो ये जो मैन इन द मिडल अटैक है ये खत्म हो जाता है, सही है ना। तो आप इसको अब लेक्चर को देख लीजिएगा तो यू विल गेट बेटर अंडरस्टैंडिंग। इट्स वेरी इंपॉर्टेंट लेक्चर एंड यू मस्ट ऑन द टीम्स यू शुड वॉच इट, डोंट वेट फॉर द वीडियो प्लीज।
Right. Thank you, sir.
ओके जी, थैंक यू जी, थैंक यू एवरीबॉडी।